Hello there, and welcome to Just About Earth, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're slowing things down a little to wander through one of the most remarkable and humbling chapters in our planet's history. You've probably heard the sound of rain before. Maybe you've listened to it from your window, soft and rhythmic against the glass. Maybe it's lulled you to sleep or kept you company while you stared out into the grey and thought about everything or nothing at all. But imagine for a moment that the rain never stopped. Imagine a world where the sound of falling water wasn't a passing weather pattern, but the background music of existence itself. Not for a day, not for a season, not even for a year, but for 2 million years straight. It sounds impossible, like something out of myth, but it really happened. Long before humans, long before forests or fish, or even the blue oceans we know today, Earth went through an age of rain so unrelenting that it reshaped the planet from its core to its clouds. It's a strange thought, isn't it? We tend to think of rain as gentle, even romantic. But in the early life of our planet, rain was an act of transformation, a storm on a planetary scale. It's what turned a world of fire into a world of water. It's what took an atmosphere thick with heat and gas and turned it into air that could someday cradle life. This was not the rain that fills puddles or patters on rooftops. It was a deluge that fell from skies of steam onto rock hot enough to glow. It didn't come and go. It didn't pause for sunlight. It fell and fell and fell until the world itself changed shape beneath it. Before we begin exploring how such a thing could happen, I wonder, where are you listening from tonight? Is it raining where you are, or perhaps clear and still? Maybe it's night time, and you can hear the faint hum of the world settling around you. Or maybe you're somewhere where the air feels heavy, the kind of quiet just before a storm. Wherever you are, let this story unfold at its own pace. There's no rush, no thunder here, only the slow rhythm of understanding how the earth once washed itself clean for 2 million years without rest. If you find stories like this soothing, a kind of calm curiosity that helps your mind drift gently through science instead of through worry, I'd be ever so grateful if you gave the video a like or subscribe to the channel. It helps this little corner of calm find others who might need a quiet moment to marvel at how strange and beautiful our planet can be. Now, settle in, breathe a little slower, and picture the world as it was 4 billion years ago, long before it became the home we know. Because to understand endless rain, we have to first step into a place where clouds were still being born. In the beginning, Earth was not blue. It wasn't green or brown or calm in any sense of the word. It was red, black, and glowing. A molten sphere still shedding the heat of its violent birth. The surface was a restless sea of magma shimmering with light from its own heat, and the air was thick with smoke and volcanic gases. There were no oceans yet, no rivers, no clouds as we think of them. The sky would have been more like a haze, an oppressive dome of chemical vapours rising from an interior, still trying to decide what it meant to be a planet. But buried in that heat was the future of everything, including rain. Scientists believe that much of Earth's early water was trapped deep inside those molten rocks, or delivered later by icy comets that bombarded the planet during its chaotic youth. Each impact brought more material, more gas, more water vapour, adding to an atmosphere so dense that sunlight struggled to break through. The air was a boiling mixture of carbon dioxide, nitrogen, methane, and steam, and for millions of years it simply swirled above a glowing crust, waiting for the world to cool enough for that steam to condense. Imagine the pressure of it, the sheer weight of all that vapour pressing down on a planet still too hot to breathe. The water couldn't fall yet. It was trapped as invisible vapour, part of a sky that shimmered with heat. The rain was waiting, patient, building itself drop by drop in a world that didn't yet have a sky. We measure time casually, in hours or days or years, but in the early Earth, time didn't move the way we experience it. Every day lasted just 6 hours. The planet spun faster, tugged and twisted by a moon that was much closer than it is now. Volcanoes erupted constantly, belching ash and gas into the air. Lightning flashed through the thick, charged atmosphere, and every bolt triggered new chemical reactions that turned simple molecules into more complex ones. It was chaos, but it was creative chaos. The stage was being set for the first rainfall, an event that would cool the surface, shape the continents, and make possible the oceans that still move beneath our clouds today. Eventually, after hundreds of millions of years of this fiery preparation, Earth began to cool. Slowly, the heat from its formation started to fade into space. The crust hardened in patches, forming primitive continents and solid ground. The air, still dense with vapour, began to change, and then, somewhere in that slow transition from fire to stone, the first droplets of liquid water formed high above the planet. They fell through the atmosphere, hit the hot surface, and instantly evaporated in bursts of steam. But with every fall, the surface cooled a little more. Every drop carried away a trace of the planet's fever. Each tiny cycle of condensation and evaporation brought Earth one step closer to its first true storm. And then, one day, the sky finally crossed the line. The vapour condensed faster than it could be returned to steam. The heavens opened and it began to rain. If you could have stood on the surface that day, though of course you couldn't have, not with the heat and the lack of oxygen, you would have seen something both terrifying and beautiful. The sky would have been nearly black, packed with clouds so dense they turned day into twilight. Lightning would have flickered through the vapour, illuminating sheets of rain that fell with no horizon in sight. The sound would have been unimaginable, a constant roar as billions of tons of water met rock and fire. The rain hissed and boiled where it landed, carving gullies in molten plains, cooling lava into glass and releasing plumes of steam that rose back up to feed the clouds again. It was a loop, a feedback that would continue without pause for 2 million years. This was not a storm in the way we think of storms. It wasn't a front passing through, nor a system that drifted across the sky. It was the sky. Every inch of it was involved in the process of cooling the planet. As the rain continued, the surface temperature dropped further, and the water that once flashed into steam began to pool in the low places. Those pools grew into lakes, and the lakes merged into basins. Slowly, under endless rainfall, the first oceans began to form, and as they spread, they reflected the dim light above, turning the planet from glowing red to a deep, shifting blue. The Earth was changing its face, trading fire for water, and it was doing it under a sky that never stopped weeping. You might wonder how scientists know this happened. After all, no one was there to watch. The evidence comes from the oldest rocks we've ever found, ancient minerals that still hold traces of the conditions in which they formed. Some of these minerals, tiny crystals of zircon found in Australia, are more than 4.3 billion years old. Within them are signatures of water, hints that liquid water existed on Earth far earlier than we once thought. The isotopes trapped in these crystals tell a story of cooling, condensation, and an environment where rain could fall for unimaginable spans of time. It's not a myth. It's written in the stone beneath our feet. The idea that Earth once rained for 2 million years is not just a poetic exaggeration. It's based on the thermodynamics of cooling a planet and the sheer volume of water needed to form oceans. The heat trapped in the crust had to be drawn out gradually, and rain was the vehicle that carried it away. Each droplet absorbed a fragment of heat as it fell, and released it when it turned to steam. Over time, the balance shifted. More rain reached the surface than could return to the clouds. The water accumulated. The feedback loop that had sustained vapour for eons finally broke, and the deluge completed its work. What began as fire ended as ocean. Think about the patience of that process. 2 million years of unbroken rain. Every day, every hour, every moment marked by the same endless rhythm. There was no dry season, no sunshine breaking through to warm the rock. The world lived under clouds so thick they trapped their own light, creating a perpetual dusk. And yet, within that monotony, transformation was happening. The crust was solidifying, the air was thinning. Chemical reactions between rainwater and the surface were scrubbing carbon dioxide from the atmosphere, creating carbonates and stabilizing the climate. The rain wasn't destruction, it was therapy. It was the planet healing from its own violent birth. If you've ever watched a storm roll over the horizon and felt the air change, that stillness before the first drop, the scent of something raw and mineral in the wind, you've experienced in miniature what the Earth once did on a planetary scale. It's humbling to think that the rain that falls today, the water you drink, the clouds that drift over your city are all part of the same ancient cycle. The molecules that fell on molten rock billions of years ago may now be falling again, quietly, outside your window. And so the sound of endless rain isn't just a thought experiment. It's history. It's the memory of how this world found balance after chaos. That rain carved the oceans, cooled the crust, and laid the groundwork for the life that would one day wonder about it. Even now, traces of that time linger. Every river that flows to the sea is a faint echo of those ancient deluges. Every storm that rolls through our modern skies carries the same rhythm, the same physics, the same story. When you think about it that way, the rain becomes something more than weather. It's continuity. It connects the planet's first storms to the ones we feel today. It connects the fiery beginnings of Earth to the quiet nights when we listen to water and feel safe. Somewhere deep in our senses, perhaps we recognize that sound, that constant fall of water against Earth, as something familiar, something ancient that once made the world livable. The endless rain eventually slowed, but it didn't end all at once. The transition was gradual as the surface cooled and the oceans deepened. Clouds thinned. Light began to reach the ground again. Steam gave way to mist and the roar of rainfall softened into waves. The skies cleared enough to show a dim red sun filtered through the remnants of vapour. The world that emerged was unrecognisable from the one that had existed before. Oceans stretched where magma plains once shimmered. The air was still heavy, but it was breathable to the chemistry of the time. The stage was finally set for the next great transformation, the beginning of life. But for now, imagine that last long phase of the rain. Picture a horizon where sea and sky are the same grey, where every sound is water meeting water. Imagine the continents shrinking beneath the rising tide, the surface smoothing into calm, the temperature falling into balance. Imagine a silence that isn't silence at all, but the steady breath of a planet cooling into its first peace. The rain doesn't need to be dramatic here. It's constant, dependable, a soft rhythm that carried on for longer than human history by 1,000-fold. It's the first lullaby the planet ever knew. That's where our story begins, with the sound of endless rain. A planet that once burned itself into being now learns how to rest. Steam becomes cloud, heat becomes calm, and the furious energy of creation slows into something almost gentle. This is how the oceans were born. This is how the Earth learned patience. And in the quiet that follows, the world waits for what comes next. A time when the rain will stop, when sunlight will touch the water, and when the calm surface of a newborn sea will reflect the first blue sky. The world that emerged beneath the endless downpour was unlike anything that exists today. It was still restless, still unfinished, still trying to cool its own fury. The ground, where it existed at all, was dark and fractured, carved by torrents that never stopped falling long enough to dry. Rivers formed without mouths, racing downhill into basins that filled faster than they could drain. Every surface sizzled when touched by water. The air hissed, the rocks cracked, and the heat that had once defined the planet's identity bled away into the atmosphere. The storm wasn't a singular event, but a process, a 2 million-year transformation that blurred the line between sky and sea. And though it eventually ended, the memory of it never did. Every ocean, every river, every drop that falls now is a quiet echo of that forgotten storm that never stopped. At this point in Earth's story, the continents we know hadn't yet taken shape. The planet was more a patchwork of cooling crust than solid land. Volcanoes still dotted the surface like open wounds, pouring lava into basins that hardened only to crack again. The clouds above were thick with carbon dioxide and sulfur dioxide, remnants of the violent volcanic era that came before the rain. The entire atmosphere was heavy with water vapour, but now that the temperature had dropped enough for condensation, the process was unstoppable. The planet had crossed a threshold, and nature has no patience for half measures. Once the rain began, it continued until equilibrium was restored, until the crust and the clouds finally agreed on what kind of world this would be. In the modern world, storms are brief disruptions in an otherwise balanced climate. They form, release their energy, and fade away. But 4 billion years ago, balance didn't exist. The Earth was all extremes, and the storm was the mechanism that would erase those extremes. Each droplet carried heat away from the crust, and when multiplied over countless cycles, that cooling effect became planetary. The air lost pressure as water condensed. The surface lost heat as it absorbed the rainfall. The difference between sky and ground began to narrow until both settled into a new equilibrium. It wasn't fast and it wasn't gentle, but it worked. The storm that never stopped was the act of balance that made the planet habitable. If someone could have looked down on Earth from space during that time, they might have struggled to tell where the atmosphere ended and the oceans began. The planet would have appeared grey or silver, its surface obscured by clouds that reflected sunlight like a giant mirror. Lightning would have flashed continuously across the hemispheres, visible even from orbit, each bolt discharging into a world already saturated with electricity. The rain fell through air so dense it could carry rocks, ash, and molten dust suspended in its currents. The oceans forming below were far from clear. They were thick with dissolved minerals, metals, and chemical compounds stripped from the crust. These were the raw materials of future life, though life itself was still millions of years away from even the simplest beginnings. As the rain carved into the surface, it changed more than just the temperature. Water is a universal solvent, and it began dissolving elements from the rock: sodium, calcium, magnesium, iron, silicon. Every drop that touched stone carried away a trace of its composition. Over millions of years, this slow leaching built the chemistry of the oceans. The balance of salts that define seawater today was being set drop by drop under the weight of a sky that never cleared. The rain was sculpting the planet chemically as well as physically, preparing an environment that would one day support complex reactions and eventually life itself. In this way, the storm wasn't merely destructive. It was creative, though that creativity looked nothing like what we associate with calm blue seas or gentle waves. Imagine standing on one of the first pieces of stable crust that rose through the flood. The surface beneath your feet would be dark, rough, and warm, still radiating heat from below. The air would sting, a mix of steam and acid rain thick enough to taste. Every breath would feel heavy, and all around there would be movement. Waterfalls pouring off newly formed ridges, geysers bursting through fissures, rivers that vanished into boiling mist before ever reaching an ocean. The sound would be overwhelming. Modern thunderstorms come and go, their thunder rolling for minutes at most. This was different. It was constant. The unending percussion of rain meeting rock, water meeting water, clouds colliding in the upper atmosphere. It was a sound without pause, the heartbeat of a planet remaking itself through repetition. The forgotten storm changed the length of days and nights. As the earth cooled and water pooled into basins, the redistribution of mass altered the planet's rotation slightly. The moon, then much closer, raised enormous tides in the newborn oceans, dragging against the rotation and slowing it down. Over time, days lengthened from 6 hours to something closer to what we recognise now. The rhythm of the planet itself was affected by the rain. The falling water, the tidal pull and the shifting crust all conspired to stretch time in the most literal sense. The same process that cooled the surface also began to stabilise its spin, creating the regular cycle of day and night that would become so essential for life later on. The storm was writing the clock by which all future living things would measure their existence. Underneath the surface, the crust was undergoing its own changes. Water seeping into the cracks began to cool the magma below, solidifying minerals and creating the first primitive granitic rocks. These early rocks were lighter than the basaltic crust around them, so they rose, forming the nuclei of what would one day become continents. Even the highest peaks were temporary though, because the rain never relented. Erosion was relentless. Mountains dissolved almost as soon as they appeared, their material carried away into the oceans that grew deeper by the century. This constant cycle of building and wearing down became one of Earth's defining patterns. In a sense, the planet learned endurance through erosion. It learned to renew itself by losing itself, grain by grain, under the persistence of water. While the surface was transforming, the sky above was undergoing an equally important shift. The dense atmosphere of water vapour was gradually thinning as more of it condensed into rain. With every drop that fell, the air cleared a little. Sunlight, once blocked completely, began to penetrate the upper layers of cloud. At first, it was just a dull red glow, filtered through miles of vapour. But slowly the colour brightened. The sun's energy started to reach the surface, warming the water instead of the rock. This subtle change in where heat was stored had enormous consequences. It created temperature gradients between ocean and air, setting in motion the first true weather systems. The storm didn't vanish, but it began to develop structure. Winds formed, currents shifted, and rain fell in rhythms rather than in unbroken sheets. The world was learning what weather meant. The forgotten storm also left behind a chemical signature that still shapes Earth's atmosphere today. As water interacted with volcanic gases, it stripped carbon dioxide and sulfur dioxide from the air, binding them into rock as carbonates and sulfates. Over time, this process reduced the greenhouse effect that had kept the planet so hot. Temperatures dropped further, eventually stabilising at a range where liquid water could persist. Without that long rainfall, Earth might have remained a boiling world like Venus, its surface too hot for oceans to exist. The difference between a world of fire and a world of life was, quite literally, the persistence of rain. There's something strangely comforting about that. The same process that could erode mountains and flood continents also brought balance. It shows that destruction and creation are not opposites on a planetary scale. They're phases of the same process. The storm that never stopped was not a punishment or catastrophe. It was a recalibration, a long exhale after the chaos of formation. When it finally eased, the world that emerged was cooler, calmer, and infinitely more capable of sustaining change. In that way, the storm wasn't forgotten by the planet. It was absorbed into its rhythm. The oceans that covered most of Earth after the storm subsided were vast and unfamiliar. They were not yet blue in the way we imagine them. The water was cloudy, filled with minerals and suspended particles. The atmosphere still held traces of volcanic gas, giving the sunlight a reddish tint. If you could look across the horizon, you might see faint outlines of islands, their surfaces dark and steaming, surrounded by mist. It would be a quiet scene, but only on the surface. Beneath those waters, chemistry was happening. Minerals dissolved by the rain mixed with energy from volcanic vents at the ocean floor, creating a rich, reactive soup. Though no organism yet stirred, the building blocks of life were assembling molecule by molecule. The forgotten storm had laid the groundwork not just for oceans, but for biology itself. There's a kind of poetic symmetry in that, though the process itself was purely mechanical. Water fell, rocks reacted, gases condensed, and heat escaped into space. Yet from those simple exchanges, complexity emerged. Over immense spans of time, those oceans that began as boiling runoff from volcanoes would host the first self-replicating molecules. Life would arise not in spite of the storm, but because of it. The planet had to weep before it could breathe. The same chemistry that made the rain acidic also provided the ingredients for organic synthesis. What was once destructive became nurturing. The storm may have stopped, but its legacy was permanent. Every drop of rain that falls today still follows the same rules established back then. The water cycle we learn about in school, evaporation, condensation, precipitation, is a direct descendant of that ancient process. The planet still breathes in vapour and exhales rain. The only difference is scale. What once covered the entire world for millions of years now happens in smaller local rhythms. Storms come and go, but the engine behind them is the same. The forgotten storm never truly ended, it just slowed enough for us to live beneath it. You can almost imagine the sound of that world if you listen closely. The soft repetition of rain on water, the low rumble of distant thunder, the hiss of steam rising from fresh rock. Those sounds have never disappeared from the planet. They're woven into every storm we experience, a reminder that water is not just weather but memory. It remembers its own origins, even if we don't. Each rainfall carries the same molecules that once cooled the planet and sculpted its surface. They've been part of clouds, rivers, glaciers, and oceans billions of times over. When you hear rain, you're hearing history. The planet telling the same story it told at the beginning, only more softly now. Eventually, the endless rain reached a point of balance. The oceans had deepened enough to hold the majority of Earth's water, and the atmosphere had stabilized. The steam that had once fed the storm dissipated. Skies cleared in places, allowing sunlight to reach the surface consistently for the first time. With light came colour. The planet shifted from the grey of clouds and the black of basalt to shades of blue and green. It was still a raw world, but it was beginning to look like something recognisable. The forgotten storm had completed its work. The Earth was no longer a furnace or a flood. It was a home waiting for life to move in. But even then, the planet wasn't entirely at peace. The heat trapped inside continued to drive volcanic activity. The air was still thick, the seas restless. There would be more rain, more floods, more reshaping to come. The storm might have ended in its constant form, but the habit of change was permanent. Earth had learned to regulate itself through cycles, heating and cooling, evaporation and condensation, balance and imbalance. That pattern would define everything that followed. And so, even after the last of the endless rain had fallen, the atmosphere still shimmered with moisture. The clouds, reluctant to vanish, drifted slowly, releasing intermittent showers that echoed the memory of what had been. The planet once again was pausing between breaths. In those quiet intervals, something remarkable began to happen beneath the waves. Simple chemistry turned into complex chemistry. Molecules began to link and fold, forming chains that could store information and replicate themselves. The oceans that the rain had created were no longer just basins of water. They were laboratories of possibility. The storm had built the setting, and now the experiment could begin. The world that had spent 2 million years cooling under constant rain was ready to host the first flicker of life. That, however, is another step in the journey. For now, what remains is the echo of the storm, the memory of a planet transformed by its own persistence. The forgotten storm that never stopped wasn't just a meteorological event. It was the beginning of stability, the first long breath after chaos. It was the sound of Earth finding its rhythm, a rhythm that continues every time the clouds gather and the first drop touches the ground. The same rain, the same water, the same slow balance repeating itself across ages, never truly forgotten. Before the rain began, Earth was a world that would hardly seem familiar to us. It was a restless, glowing planet, not yet old enough to know calm or balance. The surface was an ocean of molten rock, constantly shifting, cooling, cracking and reforming. Volcanoes were everywhere, thousands of them, each one releasing heat, gas and light into an atmosphere that was thick and toxic. The air shimmered with energy, heavy with carbon dioxide, nitrogen and steam. The pressure was immense, the temperature unbearable, and above it all hung a sky that wasn't blue or grey, but an opaque haze of orange and red. Nothing about it resembled the peaceful world that rain would one day make. This was Earth, before water, before clouds, before anything could fall from the sky except fire. It's strange to imagine a planet without oceans. We're so used to thinking of the Earth as blue that it's hard to picture it any other way. But in those first hundreds of millions of years after its formation, the surface was so hot that even metals and rocks behaved like liquids. There were no continents, no rivers, no soft ground. Everything was fluid, churning, and glowing from within. The air wasn't breathable, not even close, but it was thick enough to trap the heat that the young planet couldn't yet release. The entire world was under a kind of atmospheric blanket, made not of clouds but of gases from constant volcanic eruptions. The crust was thin and fragile, floating like a cracked shell on top of the molten interior. Beneath that, the core was still separating, with heavier elements sinking inward and lighter ones rising outward. The planet was forming its structure, but it was far from stable. This was the time before balance, when heat and gravity competed for control. The Earth had only recently survived its most violent birth pangs, collisions with other planetary bodies, including one massive impact that likely gave rise to the Moon. That impact had stripped away part of Earth's outer layers and sent debris into orbit, where it eventually coalesced into the Moon we know today. The energy from that collision was immense. It left the Earth glowing hot for millions of years afterward. Temperatures at the surface were well above the boiling point of any liquid water. Any molecule of water that tried to exist was instantly broken apart or vaporized. The idea of rain in such a place would have been absurd. There were clouds, but they were made of ash, dust, and vaporized rock, not water. And yet, even then, the ingredients for rain were already present. Deep inside the molten planet, hydrogen and oxygen, the two elements that make up water, were locked within minerals and magma. Every volcanic eruption released a little of that trapped water as vapor. Over millions of years, those gases accumulated in the atmosphere. It wasn't much at first, just wisps of steam mixing with the heavier gases above. But as the planet continued to erupt, the atmosphere thickened, layer by layer, into a dense shroud of vapor and gas. The air would have been heavy enough to press against your chest like deep ocean water if you could have stood there. But you couldn't. The surface was still too unstable, too hot, and too bright. This was a world still deciding what kind of planet it wanted to be. The young Earth was part of a solar system still filled with chaos. The sun was smaller and dimmer than it is today, and the space around Earth was littered with debris, remnants of planetary formation that still rained down as asteroids and comets. Some of those comets carried ice, and when they struck, they delivered more water to the planet. Each impact added vapor to the atmosphere and energy to the surface. Some scientists think that much of Earth's water may have come from those icy visitors, melting on impact and adding their mass to a world already rich in volcanic steam. Others believe that most of the water was there from the beginning, trapped in the rock itself, waiting to be released. Either way, by the time the heavy bombardment of space debris slowed, Earth was wrapped in a thick, suffocating atmosphere of steam and gas. It's difficult to imagine what the sky looked like then. It wasn't clear or open in any way we would recognize. The sun might have been only a faint orange glow behind miles of vapor. The light that did reach the surface would have been scattered, diffused, tinted by minerals and gases suspended in the air. The result would be a kind of perpetual twilight, not dark, but never truly bright either. The horizon would have blurred into the sky, and the sky into the ground. Everything shimmered with heat and motion. It was beautiful in its own way, though not a beauty meant for eyes. It was a world made of process, not permanence, a planet still under construction. In this stage of its life, the Earth didn't yet have what we'd call weather. Weather requires contrast, warm and cool, dry and wet, rising and falling air. None of that existed yet. The atmosphere was nearly uniform, heated from below by the molten surface and insulated by the thick blanket of gas. There were no winds, no breezes, just convection currents that moved slowly through the air like waves of invisible lava. The first true storms were still millions of years away, but in those slow, swirling motions, the seeds of rain were forming. Every molecule of water vapour rising from the magma was a small contribution to a future that the planet couldn't yet foresee. The surface of the Earth was dominated by volcanoes, not the isolated cones we think of today, but vast networks of fissures that stretched for hundreds of kilometres. Magma flowed from them in rivers, spreading across the surface in molten waves. When it cooled, it cracked and split, creating new paths for the next eruption. Each outpouring of lava released more gases into the air, feeding the atmosphere that was building above. The planet was, in effect, manufacturing its own sky, and that sky was not yet friendly. The gases were toxic to anything we'd recognise as life. Carbon monoxide, sulfur dioxide, ammonia. Every eruption made the air thicker, darker and heavier, but also more complex. Chemistry was happening even in that chaos. Molecules were combining, separating, reacting in ways that would eventually give rise to the compounds necessary for life. The Earth was violent, but it was also creative in its violence. If you could have hovered safely above that world, watching from a distance, you might have seen what looked like a furnace glowing through fog. Lightning flickered through the haze, triggered by the static of constant volcanic ash. Each bolt lit up the surface for a fraction of a second, revealing a landscape of motion, rivers of lava, plumes of gas, impact craters still glowing at their edges. The heat escaping into space would have made the planet look like a faintly glowing ember against the darkness. Even from afar, it would have been obvious that this was a planet in transition. The molten glow beneath was the last trace of its violent birth, and above it, the first whispers of a future climate were forming. The atmosphere during this period was what scientists call a reducing atmosphere, one that lacked free oxygen. Instead, it was rich in hydrogen, methane and ammonia, all of which made it highly reactive. In such an environment, chemistry was dynamic. Ultraviolet radiation from the sun, lightning from volcanic storms, and the constant exchange between rock and vapour all drove reactions that produced complex molecules. These early reactions would later form the foundation for organic chemistry, but for now, they were simply part of the background hum of creation. Every spark in the sky, every burst of heat, every molecule that collided with another was part of the slow preparation for rain, and everything rain would make possible. The pressure in the atmosphere during this time was immense, perhaps hundreds of times greater than what we experience today. Under those conditions, water couldn't yet condense into liquid droplets. The vapour simply stayed suspended, a thick blanket of steam hugging the surface. It was a strange balance. The planet needed to cool enough for rain to form, but the very gases that would create rain were also trapping heat. It was a feedback loop that kept the surface molten longer than it otherwise would have been. Only when volcanic activity began to slow and more heat escaped into space did the balance finally start to tip. As the upper layers of the atmosphere cooled, the first thin clouds began to form. They weren't clouds like ours, soft and white and drifting through blue. They were dark, dense and heavy, filled with chemical vapours and metallic dust. The tops of those clouds may have stretched hundreds of kilometres high, towering above a world that was still mostly liquid. The first droplets of rain probably formed within those clouds, but never reached the ground. The air below was still too hot, so the droplets evaporated long before they touched the surface. The sky may have glittered with falling steam that turned back to vapour before landing, a kind of ghost rain that hinted at what was to come. Meanwhile, the surface continued to change. Lava cooled into solid rock, then cracked as it contracted, forming jagged plains and ridges. Some of these solidified sections became the first crust, fragile, thin, and constantly recycled by new eruptions. But with each cooling cycle, more of the planet's heat escaped. Over millions of years, the balance shifted further. The clouds grew thicker, the air denser, and the vapour began to condense more easily. The first real rainfall was approaching, but the world wasn't ready to receive it yet. The surface was still too hot to hold water, so every drop that fell instantly turned to steam. But with every cycle of condensation and evaporation, the atmosphere lost a bit more heat. The feedback loop that had kept the world dry was weakening. This was the slow prelude to the Great Rain, a time of gathering pressure and potential. The planet was essentially holding its breath, waiting for the right temperature, the right chemistry, the right balance of gases. When that moment came, the transition would be sudden. Once the first sustained rain began to fall faster than it could evaporate, there would be no stopping it. The sky would collapse inward in a global storm lasting millions of years. A downpour that would cool the surface and fill the basins waiting below. But before that could happen, the atmosphere had to finish preparing itself. It's remarkable to think that all of this, the oceans, the climate, the conditions for life, began with something as simple as cooling. The laws of physics did all the work. There was no plan, no foresight, just energy finding its way toward balance. The molten earth radiated heat into space, and space, being cold and vast, accepted it. Over time, the planet lost enough heat to allow condensation. It wasn't a decision or a miracle, just inevitability. The same process that makes a kettle whistle or a window fog up was happening on a planetary scale. The only difference was the time scale. Millions of years instead of moments. If you were to compress that time into a single human lifetime, the transformation would look almost instantaneous. You'd see a world of fire slowly dim into red, then brown, then grey, as clouds thickened above it. You'd watch the glow fade until the first flashes of lightning appeared in the dark sky. You'd hear the first drops hiss against a rock and vanish in steam. Then you'd see the horizon blur as the air thickened with rain. The surface would stop glowing. The heat would fade. The planet would go from light to shadow, from fire to water. The earth would exhale and the first true rain would begin. But for now, in this moment before the downpour, the world was still holding that breath. Every volcano, every cloud, every molecule of steam was part of the build-up. The heat of creation was nearly spent, and the sky above was poised on the edge of change. It was only a matter of time before the heavens opened and the planet began the long process of washing itself into the world we now know. The moment before the rain began was a fragile balance between fire and vapour, a planet teetering between burning and cooling. The air was heavy, dense, and restless. A sky made of steam so thick that sunlight barely reached the ground. Below it, the surface glowed, a vast expanse of molten rock and volcanic flame. The world was caught between two states, neither solid nor liquid, not yet the blue marble we know, but not entirely the glowing ember it had been. The heat from the crust met the moisture from the sky in a ceaseless exchange. Water vapour condensed, fell, and evaporated again before it could touch the ground. It was a cycle that repeated endlessly, building pressure, gathering clouds, preparing the world for the long storm that would come. This was a time when the planet's heartbeat was volcanic. Every horizon shimmered with the dull red glow of magma flows, each eruption feeding the atmosphere with more steam and gas. Volcanoes were not rare features, they were the landscape itself. They stretched across the planet in unbroken chains, opening vents that bled heat from the mantle into the open air. Each eruption released immense plumes of sulfur dioxide, carbon dioxide, and water vapour. The sky above became a mirror to the ground below, both seething, both alive, both in motion. The boundary between them was blurred by heat. Looking up, you wouldn't see a sky as we think of it, but a turbulent canopy of smoke and vapour that rolled like an ocean turned upside down. The Earth at that time was not a planet of land and sky, but two seas, one of fire below, one of steam above, constantly feeding each other. Scientists studying this era often described the young Earth as a planetary pressure cooker. It was a closed system of immense energy. The heat trapped in the interior had to go somewhere, but the thick blanket of steam in the atmosphere prevented it from escaping easily. That heat radiated outward, but instead of dissipating, much of it was reflected back by the dense clouds, creating a greenhouse effect far more intense than anything known today. Temperatures at the surface hovered near 1,000 degrees Celsius. The crust, where it existed, was thin and unstable, constantly melting and reforming. The entire planet was, in essence, still cooking itself, and yet, even in that chaos, something remarkable was happening. The elements that would one day define the oceans, the air, and the soil were already mixing and reacting. The constant churning of molten rock, the endless plumes of vapour, and the flashes of lightning through the clouds were creating a global chemistry lab. The interaction between the atmosphere and the molten surface allowed gases and minerals to exchange freely. Iron oxidized, silicates solidified. Simple molecules like methane, ammonia, and hydrogen sulfide filled the air. Every spark of lightning triggered new reactions among them, forming traces of more complex compounds. Though the world was far from habitable, the foundation for everything that would come later was being laid in those interactions between fire and steam. If you could have stood at a safe distance, watching the Earth from somewhere beyond its atmosphere, it would have been both beautiful and unsettling. From space, the planet would have appeared shrouded in white and grey, its cloud tops thick and swirling. Occasional bursts of red and orange would break through where volcanic eruptions pierced the cloud layer. Lightning would have lit up the clouds from within, flickering like pulses of breath through a living organism. It would not have looked like the blue and green sphere we recognise, but like a living furnace slowly cloaking itself in vapour. Beneath that vapour, the surface was in constant motion. Rivers of molten rock carved paths across the planet's crust, sometimes colliding and merging into new flows, sometimes cooling just enough to form jagged, unstable land masses that floated for a while before breaking apart again. There were no continents, no stable ground, only shifting, glowing fields that rose and fell like the tide. The relationship between the steam-filled sky and the fiery surface below was not simply visual, it was dynamic. The water vapour in the air came directly from the molten rock beneath, released during eruptions or as magma cooled and degassed. In return, that same vapour trapped the planet's heat, slowing the cooling process. It was a feedback loop that defined this entire era. The hotter the planet, the more vapour filled the air. The more vapour, the more heat stayed trapped. This standoff continued until the balance finally tipped, until cooling from above outpaced heating from below. When that happened, condensation would begin in earnest, and the rain would finally fall. But before that equilibrium was broken, the planet lingered in this strange state of tension, a world of fire trapped inside a sky of steam. The atmosphere during this time would have been suffocating by modern standards. Its pressure may have been hundreds of times greater than what we experience at sea level today. Walking through it, if such a thing had been possible, would feel like moving through water. The heat would be unbearable, and the humidity absolute. The clouds above would have been in constant flux, their colour shifting between shades of grey, yellow and deep red as the light from volcanic fires below filtered through them. The sound of this world would not be silence or even wind, but a deep, continuous roar. The movement of the molten crust, the eruptions, the thunder, the rain that evaporated as it fell, all of it blending into a single, endless vibration. It was not a peaceful place, but it was alive in every sense that a planet can be. Everywhere on that young Earth, the same process repeated. Volcanic plumes rose high into the atmosphere, spreading clouds of ash and gas that reflected heat back toward the surface. Beneath them, the rain of molten rock cooled into solid crust, only to crack again as new magma pushed through. The ground was never still. The surface expanded and contracted constantly, releasing more gas into the atmosphere each time. These volcanic gases didn't just build the atmosphere, they transformed it. The release of carbon dioxide and water vapour created the first greenhouse blanket, while the introduction of sulfur compounds contributed to the early chemistry that would later help regulate temperature. What we now think of as environmental balance was, in this early age, pure consequence. Every reaction led naturally to the next, guided only by the physics of heat and pressure. In some ways, this stage in Earth's history was the most dramatic transformation the planet would ever undergo. Later ages would bring life, continents, and shifting climates, but none of them would change the planet as completely as this one did. The formation of a stable crust, the accumulation of a dense atmosphere, the slow cooling of the mantle. These were the fundamental processes that made everything else possible. Without this prolonged period of fire and steam, there could never have been oceans, rain, or air. The planet had to endure extremes before it could sustain balance. When the first real clouds began to form, not just vapour but true water clouds, they would have been unlike anything we've ever seen. They were enormous, spanning thousands of kilometres, their tops reaching high into the atmosphere where temperatures finally dipped low enough for condensation to occur. The energy released by this condensation fueled even more turbulence, driving updrafts and lightning storms that dwarfed anything modern weather could produce. Each bolt of lightning carried enough power to split molecules apart and recombine them into new compounds. Some scientists believe that these early storms may have played a key role in synthesizing organic molecules, amino acids and simple hydrocarbons that would later serve as the raw ingredients for life. In this sense, the stormy skies above the molten planet weren't just chaotic, they were creative. There's a strange duality in that image. A world at its most violent also being a world at its most fertile. It's a reminder that life and destruction often share the same stage. In the boiling atmosphere of the early Earth, chemistry was being driven by both extremes, the heat from below and the cooling from above. The result was an environment rich with energy, constantly recycling, constantly changing. Each eruption added new material to the atmosphere, and each cooling phase drew it back down again. It was a planet caught in an endless experiment, testing every possible combination of elements until one of them, much later, would lead to something that could breathe. Meanwhile, deep within the molten seas, convection currents were slowly carrying heat away from the planet's interior. These currents moved magma from the deep mantle toward the surface, where it cooled and solidified, only to sink again when it became denser. This cycle helped distribute heat more evenly, and played a major role in eventually stabilizing the planet's surface. The crust that formed during this time was primitive and thin, but it represented the beginning of geology as we know it. From then on, Earth would have a surface that could move, shift, and recycle itself. Tectonic processes were being born even before the rain began. The planet was already developing a heartbeat of its own, a slow pulse of creation and destruction that would never stop. For millions of years, this world of fire and steam persisted. The heat continued to escape, the atmosphere continued to cool, and the tension between sky and surface grew sharper. Somewhere in that process, the balance tipped. The air could no longer hold all the water vapour it contained. Tiny droplets began to form in the clouds, coalescing into larger ones, falling faster than they could evaporate. The first true rain was beginning, though it would still take time before the surface was cool enough for it to survive the fall. Each droplet that reached the ground flashed into steam, but each also carried away a fragment of heat. Slowly that cumulative cooling began to win. In a sense, the sky itself collapsed. The vapour that had shrouded the planet condensed into liquid, and gravity pulled it down in an unending cascade. It must have been a sight beyond imagining, the entire atmosphere falling as rain. The boundary between heaven and earth vanished completely. Steam rose from every surface as rain met molten rock, and the cycle repeated on a scale so vast it could only be measured in geological time. The ocean was forming, not from rivers or lakes, but from the air itself. The sky of steam was turning into a sea of water, and the sea of fire below was finally beginning to cool. The transition wasn't sudden. It didn't happen in days or weeks, but over countless years. Yet once it began, it couldn't be stopped. The planet had reached a point of inevitability. The greenhouse blanket that had trapped so much heat was now thinning. The rain was pulling gases out of the air, dissolving them into the forming oceans. The surface was cooling enough for crust to harden and stay hard. Volcanic activity still raged, but the overall balance was shifting from fire to water. The earth was trading its molten heart for a liquid skin. It's humbling to think that our oceans, the same vast expanses that now regulate climate and cradle life, were born from that tension between heat and vapour. Every wave, every droplet, every tide is a relic of that transition. The water that fills our seas once filled the air, suspended above a planet that hadn't yet learned to rest. The rain that fell to create those oceans didn't come from rivers or glaciers, but from the sky itself, condensed from a vapour that had wrapped the planet for eons. It's a simple exchange of energy, but on a scale so immense it reshaped the entire world. When the last of the atmosphere's steam had fallen and the planet's temperature stabilised, Earth entered a new era. The once fiery surface was now covered in water, its glow replaced by reflection. Clouds still lingered, but they no longer smothered the planet. The sky cleared enough for sunlight to reach the surface, scattering through the atmosphere and painting it blue for the first time. The sea of fire had become the sea of life's potential. The crust had cooled enough to hold continents, though small and scattered, and the first cycle of rainfall, evaporation and condensation, the water cycle, was fully in motion. The story of a sky of steam and a sea of fire is, in the end, the story of transformation through endurance. The Earth didn't choose to become a water world. It simply followed the rules of physics. Heat seeks cold, vapour seeks condensation, chaos seeks balance. The rain that would fall for 2 million years was not an anomaly. It was the natural consequence of those rules playing themselves out. What began as pressure became release. What began as fire became calm. The world had been tempered by its own extremes, and in doing so, it became capable of everything that followed. And yet, even as the last clouds of steam thinned and the surface settled, the planet wasn't done changing. The oceans were forming, but the rain still had work to do. There were minerals to dissolve, gases to scrub from the air, and temperatures to regulate. The balance had shifted, but the process was still underway. The Earth had entered its long, wet age, a time when the sound of falling water would echo without pause, reshaping the world again and again until it was ready to host the next stage of its story. There must have been a moment, somewhere in that endless balance between vapour and fire, when the first real drop of water made it all the way down. Not a wisp of steam or a flash of mist, but an actual droplet, cool enough to reach the surface before being swallowed by heat. Maybe it landed on a ridge of cooling rock and vanished instantly, leaving only a whisper of steam that rose back into the haze. Maybe it struck the molten ground and hissed as it disappeared. It wasn't special in itself. not aware of being first, but in that instant something irreversible began. The planet had reached the point where rain could exist, even briefly. The sky was no longer entirely made of steam. The cycle that had been suspended for so long was beginning to turn. For millions of years before that, water vapour had hung heavy in the air, locked in a stalemate with the planet's heat. The Earth had been too hot for rain to survive and too cold in places for vapour to remain purely gas. Everything lingered in between, a world of potential but no release. Then, as the crust cooled and the upper atmosphere began to thin, small changes began to cascade into larger ones. The temperature difference between the ground and the sky increased just enough for condensation to occur. Tiny droplets formed in the clouds, merging into heavier ones that could fall. Most of them never reached the surface. They turned back to steam long before landing. But slowly, more and more of them began to make it down. The first real rain had begun, and with it came the start of Earth's long transformation from furnace to ocean. It's difficult to grasp the scale of that moment. We think of rain as something ordinary, a background detail in our lives. But on that young Earth, it was an event of planetary magnitude. Every drop carried energy, heat absorbed from the air and released when it hit the ground. Every drop was part of a massive exchange between sky and crust, atmosphere and mantle. The cooling effect was cumulative. The more rain that fell, the more heat was carried away. The more heat that escaped, the more vapour condensed into clouds. It was a feedback loop, a positive one this time, and once it began, it accelerated. The first rain didn't stop. It built on itself, growing heavier and more frequent until it became the deluge that would last for 2 million years. In the beginning, the rainfall must have been violent. The sky, overloaded with moisture, collapsed inward. The air itself seemed to fall, a torrent of water descending through a haze of steam. The sound would have been deafening, a constant roar as rain met rock and exploded into vapour. Thunder rolled endlessly, echoing through the dense atmosphere. Lightning flashed with every collision of cloud layers, igniting chemical reactions in the air and illuminating the storm from within. To stand anywhere on the surface, if that had been possible, would have been like standing inside a boiling ocean. The distinction between sky and ground had dissolved. Everything was motion, heat, and water. But even in that chaos, the planet was changing. The rain cooled the surface faster than any other process could have. Lava flows hardened into rock. Basaltic crust thickened. The constant washing of water over the surface began to dissolve minerals, carrying them away into newly forming basins. The chemistry of the planet's skin was shifting. Carbon dioxide from the atmosphere dissolved into the rain, forming weak carbonic acid that reacted with the rock. Those reactions pulled greenhouse gases out of the air and locked them into stone as carbonates. The more it rained, the less carbon dioxide remained aloft, and the cooler the world became. It was self-regulating, the first example of Earth's natural feedback systems, a pattern that would continue for billions of years. If you could have seen the surface then, you might have witnessed entire regions changing in real time. Great fissures filled with rainwater only to boil it away moments later. Lava plains cracked under the stress of rapid cooling. Steam vents hissed where water seeped into cracks and reached the magma below, bursting outward again in jets of vapour. The planet was alive with sound and motion. Rivers of boiling water carved channels into soft rock, leaving behind the first traces of erosion. It was a world of extremes, but each storm, each drop, each cycle of evaporation and condensation brought it closer to stability. Eventually the rain began to persist. The ground cooled enough that water could remain liquid for longer stretches before turning back into steam. Pockets of standing water appeared. Not yet oceans, but shallow pools that reflected the dim light filtering through the clouds. They were hot and mineral-rich, their surfaces constantly disturbed by falling rain and bursts of gas from below. These pools grew, merged, and spread. slowly covering the landscape. For the first time, there was liquid water on Earth that did not immediately vanish. That simple fact changed everything. Liquid water is one of the most powerful agents in nature. It dissolves, carries, shapes, and transforms everything it touches. Once it appeared, it began to sculpt the planet. The surface, once defined by fire, was now being redrawn by erosion. Rain carved gullies through the crust, carrying sediments toward the lowlands. The minerals dissolved in the water began to accumulate in basins, altering the chemistry of those early pools. The constant rain enriched the surface with materials from deeper layers of rock. Iron, magnesium, calcium, and sodium all entered solution, setting the stage for the chemical complexity that would one day support life. The interaction between the rain and the planet's surface wasn't only physical, it was chemical in the most fundamental sense. The steady downpour created an environment where countless reactions could take place. When water meets rock at high temperatures, it produces new minerals and releases gases. These processes began to change the composition of both the atmosphere and the crust. The rain was cleansing the sky, pulling gases from it and binding them into solid form. At the same time, it was seeding the surface with compounds that would eventually support organic chemistry. The first drop that reached the ground set off a chain reaction that would echo through every later stage of Earth's history. The transformation didn't happen overnight. Even as rain became constant, much of it still evaporated before reaching the surface. The process was slow, but relentless. Every cycle of condensation and rainfall cooled the planet further, and the balance gradually shifted. The once fiery crust became stable in places, forming true land masses. The atmosphere, thick with carbon dioxide and methane, began to thin as those gases were absorbed. With less greenhouse trapping, the surface cooled even more. Eventually, the rain that fell stayed liquid. The air grew clearer, though still dense and hazy. The light that filtered through the thinning clouds illuminated a world completely changed from what had existed before. It's tempting to imagine that the end of the planet's fiery era brought quiet, but that's not quite true. The rain didn't stop the volcanoes, it only changed their role. Volcanic eruptions continued, but now, instead of adding to the heat, they contributed new materials to the oceans forming around them. Each eruption released minerals and gases that dissolved into the water, enriching it further. The balance between fire and water had shifted, but both forces remained active. Together they created the chemical richness that made the planet unique. The first oceans would not have been clear blue like today's seas. They were dark, almost black, dense with minerals and organic precursors. But in their depths, chemistry was happening that would define the future. As the rain continued, the scale of erosion increased. What little land there was, fragile islands of hardened rock, began to break down under the relentless downpour. The rain carved the first coastlines, the first valleys, the first sediments. These sediments accumulated layer upon layer, recording the story of transition in their composition. Scientists have found evidence of this early weathering in ancient zircon crystals, which contain isotopic ratios that suggest interaction with liquid water more than 4 billion years ago. Even in microscopic form, the traces of that first rain are still present. The planet has never forgotten it. The rain didn't just reshape the surface, it also reshaped time. As the oceans deepened and the tides grew stronger, Earth's rotation continued to slow. The gravitational pull of the moon, amplified by the mass of moving water, stretched the days a little longer. The rhythm of the planet adjusted. The first drop had started a chain of events that not only cooled the world but changed its tempo. Time, in a sense, began to move closer to the pace we know now. The connection between water and rhythm has been part of Earth ever since. Tides, cycles, seasons, all born from that early interplay between sky and sea. If we could look into those first oceans, we'd see something strange and raw. The water would shimmer with dissolved metals and elements, tinted green, brown, or red depending on the chemistry at any given place. Heat still poured from the crust below, creating plumes of steam and convection currents that stirred the oceans constantly. There was no stillness, no quiet depth yet, only movement. Yet within that movement, conditions were forming that would later allow the first organic molecules to survive. The constant mixing of heat, water, and minerals created pockets of stability amid chaos. The rain had given the planet something new, an environment capable of holding energy in delicate balance. Each new storm fed the process. Clouds continued to condense and collapse, lightning flashed endlessly, and rain poured down without pause. For 2 million years, the sound of falling water became the planet's constant companion. That sound was the heartbeat of the new Earth, steady, rhythmic, transformative. The sky that had once glowed with fire now wept, and in doing so created the conditions for everything that would follow. We often think of beginnings as moments of creation, as sparks of life or light. But for Earth, the real beginning was cooling. The first drop of rain marked not the birth of something new, but the start of balance. It was the shift from chaos to order, from heat to calm. The rain didn't add anything to the planet that wasn't already there. It simply allowed what was within to change form. It turned vapor into ocean, pressure into atmosphere, and energy into motion. That transformation continues today, in every storm and every river, in every droplet that falls and flows back to the sea. When that first drop reached the ground, it carried more than water. It carried the potential for every storm, every cloud, every rainfall that would ever come after. It was the moment when the planet's history turned from fire to water, from burning to breathing. The surface that had once glowed red was beginning to darken, to cool, to become solid enough to hold oceans. The first drop was small, but its consequence was infinite. Even now, billions of years later, the echoes of that moment remain all around us. The water that fills the oceans, the rain that falls, the snow that melts on mountain tops, all of it is part of the same ancient cycle. The same molecules that fell in that first storm still move through our clouds today. They've been frozen, melted, evaporated, and condensed countless times, but they've never left the planet. Every drop of water on Earth in one way or another is a descendant of that first one. When we listen to rain now, it's easy to forget that it's the planet remembering itself. The first drop that changed everything never truly stopped falling. It just found new forms, new paths, new rhythms. The same gentle sound that fills the air during a modern storm is the continuation of that ancient balance. Sky cooling itself, ground accepting it, the two exchanging heat in a quiet, eternal loop. The difference is that now, life listens. The Earth that received that first drop was uninhabitable, but the one that followed it would not remain so. The long rain would prepare the planet for life, cooling it, shaping it, filling it with oceans rich in possibility. It all began with that single moment, a droplet surviving the fall, landing on a world of fire and vanishing into steam. A small thing, but enough to start the slow turning of the wheel that would, in time, create everything that breathes. When the sky finally gave in and began to fall, it didn't stop. The balance that had held for so long was gone. The clouds that had been building for millions of years were no longer clouds at all, but an ocean suspended in the air. The planet's surface had cooled just enough to let water survive the fall, and gravity did the rest. The atmosphere collapsed inward, turning vapor into liquid at a scale that defies imagination. It wasn't a storm, it was the world-changing phase. The heavens descended, and for 2 million years Earth lived beneath an unbroken curtain of rain. There are moments in planetary history when the laws of physics become visible. This was one of them. The heat that had once defined the planet was finally escaping, carried upward in the breath of each droplet. The same energy that had kept the world molten was now being exchanged with the sky, released in the slow, constant rhythm of falling water. Every raindrop was a transaction, an agreement between heaven and earth. The air cooled as it gave up its vapour. The surface cooled as it accepted it. Between the two, the balance that would make life possible was being negotiated one molecule at a time. Imagine the view from above if you could somehow have looked down through the storm from space. The clouds would have been so thick that no light could pass through. The entire planet would have looked like a grey-white sphere, smooth and luminous, wrapped in its own weather. There would have been no continents to see, no blue seas, no green land. Just the unbroken motion of water and air, turning the planet into something between an ocean and a cloud. Lightning would have flashed constantly beneath the upper layers of vapour, brightening the surface like the flicker of distant fireflies in a fog. From that distance you wouldn't have heard the sound of it, but if you could, it would have been a continuous roar, the planet's first and longest song. Down below, the reality was far less peaceful. The surface was still warm enough in places to boil water on contact. Where rain met rock, steam rose in vast plumes, feeding the same clouds that produced the rain. It was a feedback system without rest. The air was filled with the scent of minerals, sulphur and metal. The sky glowed faintly from the lightning that never stopped. Day and night blurred into one dim half-light, because sunlight could barely penetrate the thick atmosphere. The planet had entered an age of endless twilight, lit only by storms, and yet the rain was doing its work. Every drop that fell carried heat away from the surface, cooling it faster than radiation alone ever could. The crust thickened. The molten plains solidified into basalt. The vast plumes of vapour condensing in the atmosphere lost their energy, and the overall temperature of the planet dropped. The air pressure, which had been hundreds of times higher than it is today, began to decrease as more water condensed and fell. Slowly the surface began to stabilise. What had once been fire was now becoming stone, and what had once been vapour was becoming sea. The scale of this rain is almost impossible to comprehend. We experience storms that last hours or days, maybe weeks in extreme cases. Imagine that continuing not for seasons or years, but for millions upon millions of days without pause. There was no weather pattern, no fluctuation, no calm between storms. The entire world was a single system, a storm so vast it wrapped the entire planet. The rainfall was relentless, measured not in millimetres or inches, but in oceans. Over time, those oceans began to fill the lowlands, merging into basins that deepened with every passing century. The surface that had once been molten and rough was now being smoothed and eroded, carved into the first outlines of terrain. Valleys became channels, channels became basins, and basins became seas. In those early ages of constant rain, the atmosphere changed as much as the surface did. The water falling from the sky absorbed carbon dioxide and sulphur dioxide from the air, creating acid rain that reacted with the rock below. These reactions removed greenhouse gases from the atmosphere and locked them away as minerals. Each drop of rain pulled the planet closer to stability, cooling it not only through temperature but through chemistry. The air that had once been suffocating with gas was now being cleansed, stripped of its heaviness. The endless rain was not a punishment but a purification, a slow, mechanical washing of a planet that had been born from violence. The first true oceans formed during this time. They began as scattered pools that grew until they connected, covering the surface in vast stretches of dark, hot water. The rain that filled them carried with it dissolved minerals and gases from the atmosphere, giving those oceans a strange chemistry, acidic, metallic, and alive with reactions. Hydrothermal vents, where seawater met magma, spewed plumes of minerals into the deep. These were not the tranquil blue oceans we know, but cauldrons of energy, restless and volatile. Even so, they represented something entirely new in the universe, a planet covered in liquid water. The rain also transformed the rhythm of the Earth itself. As the oceans deepened, their mass began to influence the planet's motion. The gravitational pull of the moon on these newly formed seas created powerful tides that slowed Earth's rotation. The day lengthened slightly, and with that the tempo of the planet changed. Time, which had once been measured in frantic 6-hour days, began to stretch towards something closer to the pace we know now. The rain wasn't just cooling the planet, it was rewriting its movement. The constant friction between tides and the moon's pull transferred angular momentum outward, pushing the moon a little farther away each year. The bond between the Earth and its satellite evolved under the same storm that shaped the surface. For 2 million years the process continued. Rain fell, oceans filled, and the crust cooled. Volcanoes still erupted, but instead of dominating the landscape, they now interacted with it. Lava that reached the surface hissed and hardened beneath the rain, creating new landforms that cooled in hours instead of years. Ash from eruptions mixed with rainfall, forming muddy layers that settled at the bottom of the growing seas. The air remained thick, but it was no longer toxic. Carbon dioxide levels fell sharply, while nitrogen began to dominate. The sky that had once been orange and red was now turning grey, and in the dim light filtering through, the world was becoming recognisable. What's extraordinary is how complete this transformation was. Before the rain began, the planet was defined by heat and violence. After it ended, it was defined by water and calm. Every part of the Earth's system, the crust, the atmosphere, even the rotation, had been reshaped by that one long storm. The oceans that cover most of the planet's surface today are direct descendants of that rain. The water that fell then still exists now, cycling endlessly through evaporation and condensation. Nothing was lost, it only changed form. The endless rain also left behind evidence in the planet's oldest rocks. In places where the crust has survived from that era, scientists have found isotopic ratios that point to interaction with liquid water. These traces tell us that even as the rain fell, the Earth was already forming stable minerals that could only exist under cooler conditions. The transition from molten to solid, from fire to water, wasn't instantaneous, but it was thorough. The rain touched everything: atmosphere, crust, chemistry, and left nothing unchanged. It's easy to imagine that such a storm would be purely destructive, but it was also constructive. The constant erosion of rock released nutrients into the forming oceans, building the chemical richness that life would later depend on. Silicates, iron, and magnesium dissolved into the water, creating a soup of minerals and energy. Lightning and ultraviolet light continued to strike the atmosphere, driving chemical reactions that produced organic molecules. The rain carried these compounds down into the oceans, where they accumulated. By the time the storm finally ended, the world wasn't just cooler, it was ready. The rainfall itself varied in intensity across the planet, though the distinction between heavier and lighter rain hardly mattered when it never stopped. Some regions would have experienced constant deluge, others a steady drizzle interrupted by violent storms. In the upper atmosphere, the clouds were in perpetual motion, driven by convection currents rising from the cooling surface. The dynamics of those clouds were complex. As the air cooled, new layers formed at different altitudes, each one cycling vapour in its own way. The result was a self-sustaining machine, an atmosphere that rained to cool itself, cooled to condense more vapour, and condensed to rain again. It was an elegant inevitability, written into the laws of physics long before it happened. What must it have sounded like? That's a question without an answer, but one that invites imagining. The constant hiss of rain meeting steam, the booming of thunder that rolled endlessly across the sky, the crackle of lightning igniting new chemical reactions in the air. These were the sounds of the planet's first balance being found. It wouldn't have been silence or chaos, but something in between, a steady, rhythmic noise that never truly stopped. The Earth had found its voice, and it spoke in rainfall. Over the course of those 2 million years, the sky slowly changed character. As the rain pulled more vapour out of the atmosphere, the clouds began to thin. Light, faint at first, started to break through. The sun appeared as a pale disk blurred by mist. Its warmth, though gentle, began to interact with the oceans below, creating the first true cycle of evaporation and condensation. The constant rain began to falter, replaced by intervals of lighter drizzle, then clouds that cleared for brief moments. The endless twilight brightened slightly. After millions of years, the storm that had defined the planet was beginning to exhaust itself. By the time the last of the 2 million years of rain had fallen, the transformation was complete. The air was thinner, the surface stable, the oceans vast. The atmosphere that had once been a blanket of steam was now clear enough for sunlight to reach the surface consistently. The temperature of the planet had stabilised to levels where liquid water could persist indefinitely. The greenhouse gases that had once trapped unbearable heat were now balanced by carbon locked in rocks and dissolved in the sea. The Earth had achieved something like equilibrium for the first time in its existence, but that end was not abrupt. Even as the rainfall lessened, the clouds lingered. Steam still rose from the oceans, forming mists that drifted across the surface. The thunder softened into distant echoes. The planet, after 2 million years of noise and motion, was learning what quiet sounded like. The rain had sculpted not just the land and sea, but the very climate that would persist for billions of years. The world that emerged from beneath those clouds was blue, young and alive with energy. It's strange to think that we are here because of that storm. The oceans that formed during those 2 million years became the cradle for every living thing that would ever exist. The water that filled them carried the ingredients of life, delivered by rain that fell without pause for an eternity of time. Without it, there would be no rivers, no clouds, no weather, no life. The sky that fell for 2 million years didn't just shape the planet, it gave it the ability to change. When we talk about rain today, we speak of something passing, something that comes and goes. But in the scale of the planet's memory, it has never really stopped. Every storm is a continuation of that first one. Every droplet that falls from the clouds follows the same cycle that began billions of years ago. The sky still falls, just more slowly now, in patterns we can live beneath. The rhythm is quieter, but the song is the same. The world that emerged after those 2 million years of rain was completely new. The oceans spread wide, the crust cooled and thickened, the air cleared. The storm had done its work. But the balance it created was not static, it was dynamic, living and sensitive. The rain had set into motion cycles that would never end. Erosion, evaporation, weather, climate, chemistry. The planet had found its rhythm, and from that rhythm, all else would grow. The sky had fallen, and in doing so, it had built the world. And though the clouds finally thinned, their memory lingered in every droplet, every river, every sea. The planet had learned to cool, to breathe, to sustain itself. The storm ended, but the cycle began, and in that cycle was everything that would ever live. When the rain finally began to gather instead of vanish, when it stopped turning to steam and started to stay, the world took its first true shape. The oceans were not poured from rivers or filled by melting ice. They were born from the sky itself. Every droplet that fell carried a fragment of the planet's past with it, a molecule that had once been vapour trapped in the air. For 2 million years the rain had fallen without pause, and now its weight was collecting in the low places. What had once been a world of fire and vapour was slowly becoming one of water and reflection. It began quietly, at least on the scale of the planet. The rain that had scoured rock and carved valleys started to fill them. Steam still rose in thick veils wherever water touched hot ground, but less of it now. The crust had cooled, solid enough to hold the liquid that gathered upon it. Pools merged into basins, basins into lakes, and lakes into the first great seas. The surface darkened, its glow replaced by sheen. What had been a planet of light and flame became a planet of shadow and depth. From above, it must have looked as if the world had drawn a long breath and exhaled it as mist. The oceans didn't appear all at once. They accumulated drop by drop, year by year, in a process so vast it makes even geological time seem brief. The first bodies of water were small and scattered, isolated depressions that filled with rain faster than they could evaporate. Over time, as the air cooled further and the ground stabilized, these small seas began to spread. Rainwater carved pathways between them, forming channels that deepened into primitive rivers. The planet's first hydrological system was taking shape. Not yet organized, not yet balanced, but functional. Water moved, it pooled, it flowed, it returned to the sky. The cycle had begun. The chemistry of those first oceans was complex. The rain that filled them was not pure. It carried dissolved gases and minerals from the atmosphere. Carbon dioxide, sulfur dioxide, and ammonia mixed into the water, forming weak acids that reacted with the rock below. These reactions pulled even more elements from the crust: sodium, magnesium, calcium, iron. Each droplet that fell changed slightly as it interacted with the surface, enriching itself, blending with countless others to form a fluid that was more than just water. It was chemistry in motion, a solvent capable of dissolving the planet's history into itself. The seas that resulted were heavy with dissolved minerals, far saltier and thicker than the oceans we know today. They were dark, metallic, and restless, constantly stirred by volcanic heat rising from below. Volcanoes still dotted the landscape, but their presence now served a different purpose. Each eruption added new material to the young oceans: silica, metals, and gases that dissolved into the water. The heat they released kept the lower layers in constant motion, creating convection currents that circulated minerals and energy. The meeting of hot magma and cool seawater produced vast plumes of steam, rising into the air to form clouds that continued to rain down. It was a self-sustaining cycle, the oceans feeding the sky feeding the oceans. Water fell, evaporated, condensed, and fell again. The planet had found a rhythm. If we could somehow look into one of those early oceans, it would not resemble the clear blue we associate with water today. The light barely penetrated the surface, filtered through layers of vapor and cloud. Beneath the waves, the water was cloudy, tinged with green and brown from dissolved minerals. The surface boiled in places where it met volcanic heat, sending up bursts of bubbles and gas. The air above was still thick, heavy with humidity and the faint scent of sulfur. Yet, despite its harshness, it was a stable system. The heat from the planet's core was balanced by the cooling effect of the oceans and the clouds above. For the first time, the Earth was maintaining its own temperature within a range that allowed liquid water to persist indefinitely. This equilibrium was the first real sign that the planet had matured. The endless rain had done its work. The air no longer glowed with heat. The surface no longer cracked and flowed. Instead, the Earth was breathing in slow, steady cycles. Clouds formed, drifted, and broke apart. Rain fell and rose again as vapor. The oceans deepened, and their tides, driven by the pull of the moon, began to sculpt the edges of the forming continents. With every passing millennium, the water found new paths, carving deeper channels and smoother shorelines. The world that emerged from beneath the storm was no longer chaotic but patient. The oceans were not just a consequence of the rain, they were the reason it stopped. As more and more water collected on the surface, the air grew drier. The vapour that had once filled the sky was now condensed into liquid below. The pressure dropped, the clouds thinned, and sunlight began to reach the surface again. The light was weak at first, diffused by mist, but it was enough to warm the upper layers of the oceans. This warmth created the first true water cycle: evaporation from the surface, condensation in the atmosphere, and precipitation returning to the sea. The storm that had lasted 2 million years transitioned into a rhythm that would continue forever. As the skies cleared, the sun appeared for the first time in ages. The light that reached the oceans reflected back into space, giving the planet a blue hue for the first time in its existence. The colour wasn't just an aesthetic change, it was a signal of stability. Blue meant water, and water meant balance. From space, the Earth was no longer a burning ember but a calm sphere shimmering with clouds and seas. It had become recognisable, something that could be called home, even if no life yet existed to see it. The formation of the oceans marked a turning point not only for the surface, but for the interior of the planet as well. The water seeping into cracks and fissures cooled the crust from within, solidifying minerals and altering the chemical composition of the mantle. This interaction between ocean and rock set in motion processes that would one day drive plate tectonics. The crust thickened and strengthened, while the heat trapped below found new paths to escape. The world that had once been a molten sphere was now layered, differentiated and structured. The presence of water made that possible. It lubricated the movements of rock, softened the boundaries between plates, and allowed the planet to evolve dynamically rather than remain static. The oceans also began to influence the atmosphere in subtle but lasting ways. As water covered more of the surface, it acted as a buffer for temperature changes. The vast bodies of liquid absorbed heat during the day and released it slowly at night, moderating the extremes that had once defined the planet. The rain had cooled the world, but the oceans kept it that way. The carbon dioxide that had filled the air was now mostly dissolved in water, or locked away in minerals. The atmosphere, once suffocatingly dense, had thinned enough for pressure and temperature to reach levels similar to what we know today. Nitrogen, stable and inert, became the dominant gas. The skies turned from orange to grey, and eventually, when the last of the volcanic haze settled, to pale blue. It's easy to think of this transformation as inevitable, but it depended on delicate balances. If the planet had been slightly closer to the sun, the oceans might have boiled away. If it had been slightly farther, they might have frozen. The greenhouse gases that had once threatened to suffocate the planet now served to keep it warm enough for liquid water to exist. Everything, temperature, pressure, distance, chemistry, had aligned perfectly. Out of that alignment came stability, and from stability, the potential for life. The oceans born from the clouds would become the cradle of everything that followed. In those early oceans, even before life began, chemistry was already preparing the way. Lightning still flickered through the upper atmosphere, striking the surface of the seas and splitting molecules apart. Ultraviolet light from the sun penetrated the thinner layers of cloud, providing energy for new reactions. Simple organic compounds began to form: amino acids, lipids, sugars, the first building blocks of biology. These molecules collected in the shallow, warm waters near volcanic vents and shorelines. There, stirred by currents and heat, they began to combine, separate and recombine. The process was random but persistent. Given enough time, persistence finds form. The oceans themselves became enormous chemical laboratories. The minerals dissolved in the water provided catalysts for reactions that could not occur in the air. Iron, nickel and sulfur helped create complex molecules from simpler ones. The tides and currents provided movement, constantly mixing and redistributing ingredients. The rain that had once eroded the surface was now feeding the chemistry of creation. What had begun as an act of planetary cooling was slowly becoming the groundwork for biology. The oceans, once just the planet's reflection of the sky, were becoming something far more important, the medium through which life would emerge. Even without life, those oceans were dynamic and full of energy. Currents driven by differences in temperature and salinity circulated endlessly, distributing heat around the planet. These currents helped maintain the balance that kept the Earth from freezing over or overheating. The water acted as both shield and engine, absorbing radiation and releasing it slowly. The interaction between ocean and atmosphere created the first true climate patterns. Clouds formed and dissipated, winds began to shape the surface, and rainfall settled into regional cycles. For the first time, the planet had weather that changed, a sign that equilibrium had been achieved. The water that now filled the basins was ancient even then. Every molecule had existed in some form since the birth of the solar system, trapped in minerals carried by comets or condensed from vapour. The rain that had fallen for 2 million years was not new. It was recycled from cosmic origins. When it settled into oceans, it carried with it the memory of stars, of collisions, of ice drifting through space. The seas that now stretched across the surface were, in a sense, the universe remembering itself in liquid form. As the skies continued to clear, sunlight began to drive new changes. The upper layers of the oceans warmed, creating temperature gradients that set in motion the first stratification of the seas. Warm water stayed near the surface, while cooler, denser water sank below. This layering affected everything: the movement of nutrients, the chemistry of gases, the exchange of energy between ocean and atmosphere. It was another step toward complexity, another layer of balance added to the system. The planet was no longer just cooling, it was organising itself. When we look at the oceans today, it's easy to forget how improbable they are. Every wave, every current, every tide owes its existence to that long, ancient rain. The water that falls from the clouds now is the same that once fell on molten rock, that once boiled and condensed and fell again. It has moved through every phase the planet could offer and remains unchanged in essence. The oceans, born from the clouds, have never left. They've only moved, shifted and cycled through time, carrying with them the memory of their origin. It's possible to imagine the final moments of that great transformation. The last of the endless rain falling into seas that no longer steamed, the last plumes of vapour rising into skies that were finally clear. The surface had cooled enough to keep the water still. The thunder softened. The lightning grew less frequent. The Earth, for the first time in its history, saw sunlight reflected from the surface of its own oceans. In that reflection was balance, and in that balance everything that would ever live. The oceans born from the clouds were more than water. They were the planet's first act of permanence, the moment when something lasting replaced something fleeting. Vapour became liquid, heat became rhythm, chaos became order. The same cycle continues now. In every cloud that forms, every storm that breaks, every droplet that falls and returns to the sky. The rain that created the oceans never truly ended. It only slowed enough for life to appear beneath it, to rise, to fall, and to remember. By the time the oceans had settled, the planet had entered the quietest period it had ever known. The rain that had sculpted every surface, the storm that had shaken the air for 2 million years, was finally easing into balance. The world was no longer burning or flooding, it was cooling. For the first time, there was something like calm. The oceans no longer boiled, the air no longer glowed with heat, and the ground beneath the water had grown firm. The earth, still young, was beginning to rest. It was learning to sleep, in the only way a planet can, by finding equilibrium. The surface, once molten and unrecognisable, was now layered in solid rock. The crust had thickened, forming a foundation strong enough to support continents, though they were small and scattered. These early land masses were little more than islands of dark basalt surrounded by endless water. They rose and fell slowly as heat from below shifted the ground, but the changes were gentle compared to the chaos that had come before. Above them, clouds drifted in pale, steady patterns, breaking at times to let sunlight touch the new oceans. The sunlight reflected off the surface in wide, shimmering bands, casting brightness into an atmosphere that was finally clearing. For the first time, the world had colour. Blue from the water, grey from the rock, white from the clouds. The fiery glow of the planet's youth had faded, replaced by light reflected rather than emitted. The air was different now too. It no longer pressed down with unbearable weight. The thick veil of steam had condensed into oceans, leaving behind an atmosphere dominated by nitrogen and traces of carbon dioxide. The pressure dropped to levels that would one day be familiar to us. The haze of volcanic gases thinned, and sunlight reached the surface without being scattered into permanent twilight. It was still dim by modern standards, filtered by the remnants of vapour and dust, but compared to the darkness that had come before, it was dazzling. The planet that had once been hidden beneath its own clouds was now visible, to the stars, to the sun, and to itself. Cooling a planet is not a single act, but a process that continues long after the obvious signs have faded. Beneath the crust, the mantle still churned with heat, moving slowly in convection currents that carried energy toward the surface. Each eruption that broke through the crust released more of that heat into the air, but the frequency of eruptions was decreasing. The magma chambers beneath the surface were cooling and solidifying, forming layers of rock that would someday make up the continents. The volcanic activity that once defined the planet's identity had become less constant, more rhythmic. It was still present, but now it served as a kind of steady heartbeat rather than an uncontrolled pulse. The oceans, vast and dark, acted as regulators for this entire process. Water has an extraordinary capacity to absorb and release heat, and on a planetary scale it became Earth's thermal blanket. The oceans took in warmth from the crust and the sunlight above, distributing it through deep currents that circled the globe. The result was a steady moderation of temperature. Instead of dramatic swings between hot and cold, the planet now experienced a gentle balance. Even in this early stage, the oceans were shaping the planet's climate in ways that would persist forever. The rain had built the seas, and the seas, in turn, were now governing the air. If we could somehow have watched the planet during this time, it might have looked peaceful, almost serene, but that stillness was deceptive. Every calm surface hid slow movement beneath. The crust was expanding and contracting as the planet's interior released energy. The oceans were deepening, carving the seabed with weight and motion. The atmosphere was still adjusting to its new composition. The rain had slowed, but mist still rose from the oceans, feeding clouds that drifted and fell in soft, rhythmic cycles. The water cycle, evaporation, condensation, precipitation, had settled into its permanent pattern. It was the beginning of time as we understand it, time measured not in explosions but in cycles, in repetition, in the quiet pulse of a planet that had learned consistency. Cooling also meant chemistry was changing. When the surface was molten, only simple compounds could exist, but in this calmer, cooler world, more complex reactions could occur. The interaction between seawater and rock began to form minerals like clay, which could trap and concentrate molecules. These minerals would later play a crucial role in the formation of life. But even now, their appearance marked another turning point. The planet was no longer just a place of energy. It was becoming a place of storage, a place where processes could take their time. Energy wasn't just escaping anymore. It was being held, distributed and balanced. The sunlight that now reached the surface was weak compared to what we experience today. The sun itself was younger and dimmer, producing less energy. Yet, paradoxically, the Earth was warm enough to keep its oceans from freezing. The remaining greenhouse gases in the atmosphere, mainly carbon dioxide and methane, provided insulation, trapping just enough heat to maintain liquid water. The balance was delicate. If the rain had stripped too much carbon from the air, the planet could have frozen solid. If too little, it would have remained too hot for life to develop. But somehow, through the natural give and take of chemistry and weather, the planet found the exact middle ground it needed. The Earth was self-regulating long before any living thing arrived to influence it. This self-regulation is one of the most remarkable aspects of planetary evolution. The Earth, through nothing but physical law, developed a feedback system that maintained its temperature within narrow limits. Too much heat triggered more rain, which cooled the surface and reduced greenhouse gases. Too little heat slowed rainfall and allowed gases to build up again. The oceans acted as buffers, absorbing changes and smoothing extremes. It was an automatic, unconscious process, but it worked perfectly. The planet had built itself into a system that could sustain stability for billions of years. It had cooled itself, not into silence, but into balance. The evidence for this stage still exists today, locked within the oldest rocks on the planet. Ancient zircon crystals found in places like Western Australia contain oxygen isotopes that indicate they formed in the presence of liquid water. Those isotopes tell us that by 4.3 billion years ago, not long after the planet's formation, the Earth had already cooled enough for stable oceans to exist. The same rocks also show signs of crustal recycling, suggesting that even this early, plate-like movements were beginning. These records, written in minerals smaller than a grain of sand, confirm what the story of the rain implies, that the Earth had reached equilibrium far earlier than once believed. As the planet cooled, it also became quieter in another sense. The constant lightning that had once lit the skies faded as the atmosphere stabilized. Thunderstorms became less frequent, replaced by gentler rains. The clouds that had once blanketed the world in darkness began to break apart, allowing stretches of clear sky. For the first time, the stars would have been visible from the surface. Imagine that. A planet that had lived for millions of years without ever seeing the night sky, suddenly looking upward to find points of light where there had only ever been vapour. The same rain that had fallen from those clouds had now created the clarity to see beyond them. Cooling brought with it the first sense of rhythm. The planet's rotation, slowed by tidal forces, now provided days long enough for temperature differences to matter. The side facing the sun warmed slightly. The side facing away cooled. The oceans absorbed and redistributed that energy, preventing extremes. It was a stable cycle, predictable and slow. For the first time, there were mornings and nights, even if no living thing yet existed to notice them. The alternation between light and dark, warmth and coolness, was the planet's first version of rest. The Earth had entered its long planetary sleep, not a sleep of inactivity, but of balance. The energy of the planet had found new paths. Instead of being released in explosions and fire, it now moved through the slower mechanisms of weather and ocean currents. The mantle still shifted, the crust still cracked, but these movements were tempered by water. The cooling had given the planet not just stability, but endurance. A hot world burns itself out. A balanced one lasts. The rain had transformed the Earth into a system capable of surviving change rather than being consumed by it. In the depths of the oceans, where sunlight couldn't reach, hydrothermal vents continued to release heat from the planet's interior. Around these vents, rich plumes of minerals mixed with seawater, creating environments of intense chemical activity. It was in places like these that life would eventually begin. But even before life, these vents played a vital role in maintaining the planet's chemistry. They circulated elements between the crust and the sea, keeping the balance that prevented the oceans from becoming too acidic or too alkaline. The Earth was already behaving like a living organism, recycling its materials, regulating its own temperature, maintaining internal consistency. It had cooled itself into a state that would allow life, long before life arrived, to benefit from it. Cooling also affected the moon. As Earth's tides interacted with the lunar pull, energy was transferred outward, pushing the moon farther away in its orbit. The distance between them increased slowly but continuously. With each centimetre of separation, the tides grew slightly weaker, the days slightly longer. The rhythm of the planet's rotation, the heartbeat of its oceans, and the motion of its satellite were all linked. The cooling Earth wasn't just influencing its own surface. It was shaping the dynamics of the entire Earth-Moon system. Over time, the rain became part of this new rhythm. Clouds formed over the warm oceans, drifted inland across scattered islands, and released their moisture. Rivers began to appear, carrying water back to the sea. The hydrological cycle had matured, completing the circuit that would define the planet's climate forever. The rain that had once been endless and violent was now periodic, seasonal in pattern, though seasons themselves were still primitive concepts at that stage. The balance of evaporation and precipitation had reached a state that kept the ocean stable. The sky and sea were no longer adversaries but partners. In this balance, the Earth found its rest. The heat that had driven its formation had finally diffused enough for the planet to slow down. The surface temperatures stabilized, the atmosphere thinned to a comfortable density, and the cycles of water and rock reached harmony. The storms that once defined the sky were now passing events. The planet that had once burned was now calm enough for continuity. The Earth had cooled itself into a state that could last. When we say the planet cooled itself to sleep, it doesn't mean it stopped. It means it reached the point where change no longer threatened to undo it. The rest it found was not stillness, but sustainability. The same cycles that began then, the movement of air and water, the shifting of crust and mantle, continue today in endless repetition. Each day's weather, each ocean current, each geological shift is part of that same rhythm. The Earth never stopped cooling entirely. It only slowed to a pace that allows life to exist between its breaths. If we could stand at the edge of one of those early oceans, listening, it would probably sound familiar. The gentle movement of water against rock, the low hum of wind across the surface, the faint patter of rain. These are sounds we still hear today. The same forces that shaped that quiet world continue to shape ours. The difference is that now there are ears to listen. The planet that cooled itself to sleep did not do so out of exhaustion, but out of preparation. It had spent its first few 100 million years in turmoil, and now, at last, it was ready for what would come next. The oceans it had formed were stable, the temperature steady, the air breathable, not for us yet, but for what was about to begin. The calm after the long rain was not an ending, it was an intermission before life entered the scene. And so the Earth rested, not in silence, but in balance. The rain had done its work, the seas were deep, the air was clear, and the world was finally cool enough to hold its shape. The fire had given way to water, and the water had given way to calm. The planet had cooled itself to sleep, and in that long, patient rest, the conditions for awakening were forming beneath the surface. When the last of the endless rain had fallen, the planet emerged from beneath the clouds as something entirely new. For the first time in its history, Earth could see itself. The veil that had covered it for millions of years began to lift, and through the thinning mist, sunlight spilled across the surface. What it revealed was a world reborn, a planet washed clean, its violent youth cooled into stillness. The land where it existed was dark and raw, gleaming with moisture. The oceans stretched vast and uninterrupted, reflecting the pale light of a young sun that had never before reached this far. The storm was over, but its work had only just begun to show. The air still carried a faint heaviness from its long transformation. It was thick with humidity, rich with nitrogen and traces of carbon dioxide, but it was no longer the suffocating atmosphere that had once trapped the planet in its own heat. The rain had stripped away much of what had made it unbreathable. Every droplet that had fallen during those 2 million years had pulled gases from the air and bound them into the crust. The result was a cleaner, cooler atmosphere, thin enough for light to pass through, but strong enough to hold warmth. The temperature, once measured in extremes, had settled into a range that could sustain liquid water indefinitely. The Earth had, for the first time, found balance. Across the planet, steam still drifted in quiet veils from the ground. The heat of the interior continued to seep through cracks and vents, creating columns of vapour that rose into the morning sky. But even these were calmer now. The violent eruptions that had once torn through the crust had slowed, replaced by smaller outpourings of gas and lava that hardened almost as soon as they met the air. The surface of the world had cooled into stability. The crust was thicker, stronger, and less restless. The oceans that covered most of the planet acted as a vast thermal regulator, absorbing heat during the day and releasing it through the night. The Earth had become its own form of equilibrium, no longer ruled by chaos, but guided by cycles. The sight of this new world would have been both strange and beautiful. The horizon was dominated by water. Continents, as we think of them, did not yet exist. The surface was a series of dark volcanic islands scattered across endless seas. Their edges steamed faintly where hot rock met cool water. Clouds hung above them, but not in the solid, oppressive layer that had once blanketed the planet. Instead, they drifted in slow formations, gathering over the oceans and breaking apart with the wind. Rain still fell, but now it came and went, part of the rhythm rather than the rule. For the first time there were clear skies, and through them the sun burned weakly but steadily. The light that reached the surface was softer than today's, filtered through an atmosphere still adjusting to its new composition. The sun itself was younger and dimmer, only about 70% as bright as it is now, but the balance between greenhouse gases and reflective clouds kept the temperature just right for liquid water to persist. The sky would have appeared pale and hazy, shifting between white and light grey rather than the deep blue we know. It was a world of gentle contrasts, warm but not hot, bright but not blinding, calm but not still. Every element that had once fought for dominance had now settled into cooperation. Beneath the calm surface of the oceans, the story was still one of motion. The water was heavy with dissolved minerals carried there by the rain and the erosion of the young crust. Iron, magnesium and silica drifted in solution, giving the oceans a murky tint. The water was not yet blue but dark and metallic, rich with the raw ingredients of chemistry. Beneath the surface, geothermal vents released streams of heat and minerals from the mantle below. Around these vents, the conditions were perfect for complex reactions. Hot water met cold water, creating gradients of temperature and energy. The ocean floor became a laboratory where the planet continued its transformation. Not through fire now, but through chemistry. The air above these oceans would have smelled faintly of minerals and ozone, the remnants of lightning that still flashed across the horizon. Electrical storms were common in these early days, but unlike the endless downpour that had come before, they were short and intense, isolated bursts of energy that helped shape the atmosphere. Each bolt of lightning split molecules in the air, creating new compounds that drifted down into the water. Simple gases became more complex, forming carbon-based molecules that were the first steps toward life. The planet, though cooling, was still creative. It was using its new calm not to rest entirely, but to build. The cooling also brought structure to the oceans. The surface waters, warmed by the sun, began to circulate, creating gentle currents that spread heat across the globe. The deeper layers, cooled by the absence of sunlight, sank and moved more slowly. This layering of warm and cold water created circulation patterns that distributed minerals and gases evenly. It was the first sign of a global climate system, a planet not just existing, but functioning as a cohesive whole. The rain had made the oceans, but now the oceans were managing the rain. The feedback loop was complete. The rocks that had been exposed by receding water began to weather under the constant movement of wind and waves. Each grain of eroded mineral carried with it the story of the planet's transformation. Washed into the oceans, these sediments settled into layers on the seafloor, forming the earliest geological records. They were thin, unstable, and easily disturbed by the planet's slow movements, but they marked the beginning of a new kind of time, the time of accumulation, of record-keeping, of continuity. The world was no longer measured by eruptions or impacts, but by the slow layering of its own memory. The colour of the sky continued to change as the planet stabilised. With less volcanic ash and gas in the air, the light from the sun began to scatter differently. The hazy white gave way to pale blue. The same scattering effect that makes our modern sky blue was beginning to take shape, though faint and uneven. The first true blue days would have been rare, but when they occurred, they would have transformed the landscape completely. The dark seas reflected the light, shimmering with silver and grey, and the scattered islands glowed against the contrast. It was the first time in the planet's history that light and water interacted the way they do today. Reflections dancing on waves, clouds mirrored on the surface, shadows cast across calm water. The cooling also quieted the interior of the planet. The core still rotated, generating a magnetic field that shielded the Earth from solar radiation. This field, combined with the growing stability of the atmosphere, protected the surface from the worst of the sun's energy. It was another step toward habitability. The violent winds of the early atmosphere had calmed, replaced by steady breezes driven by temperature differences between ocean and air. The first recognizable weather patterns began to emerge. Rain clouds formed where the air was warm and rose, drifting toward cooler regions before releasing their moisture. The planet had entered its era of rhythm, no longer constant chaos, but the slow repetition of balanced forces. The world after the flood was not static. It was dynamic in a quieter way. The continents were still forming, pushed upward by the slow movements of the crust. The mantle below was in motion, circulating heat in vast loops that would one day drive plate tectonics. Even without life, the planet was busy. Every process, erosion, sedimentation, circulation, radiation, worked together to shape what would come next. The flood had ended, but its momentum continued in other forms. The Earth had gone from being a world that reacted violently to a world that adapted gradually. In the stillness of this new equilibrium, the conditions for life were gathering strength. The oceans, now stable and long-lasting, provided a place for organic molecules to accumulate and interact. The constant cycling of heat and minerals around hydrothermal vents created an environment where chemistry could become biology. The very balance that had cooled the planet now allowed complexity to build. The rain had ended, but the reactions it set in motion were just beginning to combine into patterns capable of replication. To imagine this time is to picture a world between states, no longer raw, not yet alive, but filled with potential. The sky was open, the air clear enough for sunlight to reach the ocean depths. The water, once a tool of destruction, had become the foundation for continuity. The same droplets that had fallen for millions of years were now part of an endless cycle of evaporation and return. The Earth had learned how to recycle itself, how to sustain the same materials through infinite repetition. The energy that once burned freely now moved slowly, deliberately, through air and water. On the surface, the temperature of the oceans hovered just below boiling in some regions and far cooler in others. This gradient of warmth and cold created zones where reactions could differ. Near volcanic vents, minerals precipitated out of the water, forming chimneys of rock that spewed jets of heat and gas. In cooler areas, these minerals settled into sediments rich in iron and silica. The contrast between these environments created diversity in chemistry, a requirement for the emergence of life. The flood had not just shaped the surface, it had prepared the chemistry of the planet's future inhabitants. The world after the flood also had silence. For the first time, there were pauses between storms, stretches of calm where nothing erupted or fell. In that silence, the planet's processes could build upon themselves. The oceans began to circulate more predictably, the crust cooled enough to resist constant melting. The weather, though still heavy, found a steady rhythm. The world that had once screamed with thunder now whispered with the sound of waves. It's strange to think of a planet cooling as an act of creation, but in many ways, that's exactly what it was. The flood that had erased the fiery world gave rise to one that could remember. Every grain of sediment, every ripple on the ocean floor, every molecule of water carried the imprint of what had come before. The earth had written its first chapter in rain, and now it was beginning to write its second in reflection. The storm was no longer outside the planet, it was within, a continuous circulation of energy that would sustain it for the rest of its life. If you could have stood on one of the few islands rising above those early oceans, the view would have been vast and empty. The horizon curved slightly with the planet, an unbroken expanse of water. The air would have been warm, humid, and filled with the faint scent of minerals. The waves, gentle but persistent, would have carried heat away from the land and into the sea. Above, clouds drifted lazily, their shapes constantly changing. It was a world that seemed peaceful but was still in motion at every scale. The slow breathing of a planet that had just learned calm after chaos. The world after the flood was not the final version of Earth. It was the foundation. The continents would still rise and drift. The atmosphere would still evolve, and the oceans would still change their chemistry. But this moment, this first calm after the long rain, was the turning point. It was when the planet became capable of sustaining complexity, when it could maintain balance long enough for something delicate to take hold. The oceans that had been born from the clouds were now deep and steady, and in their depths, life's first experiments were quietly beginning. The flood had ended, but its legacy remained in every part of the earth. The rocks carried the memory of erosion. The oceans carried the chemistry of the air. The air carried the rhythm of the sea. The planet that had been born of collisions and chaos had washed itself into balance. The flood had not been destruction but transformation. The world that followed was the proof of it, calm, patient, waiting. The storm had passed, but its heartbeat remained, pulsing softly in the movement of water against rock, in the slow drift of clouds across the sky, in the quiet rhythm that would carry the planet forward for billions of years more. The rain that once fell without end is long gone, but it never truly disappeared. It remains, carried forward through time in every drop of water, every ocean current, every cloud that forms and fades above us. It exists in the rivers that carve valleys through stone, in the snow that settles over mountains, and in the quiet mist that drifts over lakes before dawn. Every bit of water on this planet has already fallen, evaporated, and fallen again countless times. The same rain that cooled the molten crust billions of years ago now flows through us. It is in our blood, our breath, our bones. The planet may have changed beyond recognition, but the water has not. It is the one thing that has remained constant, moving, cycling, carrying memory through time. When we drink, we are taking in the same molecules that once fell on a world without life. The same hydrogen and oxygen that condensed in the planet's first clouds now fill our cells. Every sip, every breath, every drop that touches our skin connects us to that ancient storm. It is strange to think that something so ordinary, something we rarely notice, is also the oldest thing we will ever touch. The water in our bodies has been through every possible form: vapour, ice, rain, ocean, blood. It has passed through mountains and clouds, through the air we exhale, through plants, through stone, through everything that has ever lived. There is a kind of quiet continuity in that. The story of the planet is not written only in rock or fossil, but in the water that moves through everything, carrying its history silently inside itself. In the ages after the Great Flood, as the world stabilised and life began to form, water became the medium of every transformation. It dissolved minerals, transported nutrients, and provided the space for chemistry to grow complex. Within the oceans, simple molecules assembled into chains that could replicate and evolve. Those early forms of life didn't just live in water, they were made of it. Every cell was a small ocean, holding within it the same balance of salts and minerals that once defined the seas. The chemistry of the ocean became the chemistry of life. Even now, the composition of our blood mirrors that of ancient seawater, a quiet inheritance from the planet's earliest days. The connection between rain and life runs deeper than we usually notice. Every plant, every animal, every living thing depends on the same cycle that began when the first drop fell. The rain that feeds rivers also feeds roots. The rivers that carve the land also shape the soil that sustains forests. The oceans that collect the rain also give rise to clouds that carry it back again. It is a closed loop, self-sustaining, endlessly patient. Life doesn't stand apart from this cycle. It is a continuation of it. The rain never stopped falling. It just found new paths to follow, through streams, through leaves, through us. Even in our bodies, the rhythm of water continues. The majority of our mass is liquid, flowing and circulating like miniature tides. Our hearts move water just as the planet's gravity moves the oceans. Every heartbeat is a pulse that mirrors the same forces that govern the rise and fall of the seas. When we sweat, cry, breathe or bleed, we return that water to the world, adding to the same cycle that began billions of years before we existed. The planet's hydrology and our biology are not separate things. They are the same system seen at different scales, one vast and planetary, the other intimate and human. There is also memory in the movement of water. The rain that falls on your skin may have once been locked in ice at the poles, or deep within an underground aquifer, or drifting as vapour over a distant ocean. Before that, it may have fallen on the molten rock of the early Earth, hissing into steam before the oceans were even formed. Water carries no consciousness, but it carries continuity. Its molecules don't age, don't erode, don't fade. They change form endlessly, but they remain. In that sense, the water inside us is not just ancient, it is eternal. It has moved through every stage of the planet's history, and now it moves through us, linking our present to the first rains that fell on the world. If we could trace a single drop of water backward through time, it would travel an impossible path. It would pass through clouds, rivers, glaciers, oceans and storms. It would move through animals and plants, through air and stone. It would pass through countless transformations, liquid, solid, vapour, each one a return to the same essence. And if we followed it far enough, past all the ages of life, past the continents drifting and the mountains rising, we would find it suspended in the thick, hot air of a young Earth, waiting for gravity and temperature to align so that it could fall. Every drop of water that exists today once waited for that same moment. The first rain never ended. It simply became cyclical. There's a quiet symmetry in the fact that the same water that once cooled the planet's crust now cools our skin. The same droplets that shape the continents now shape us from within. Our bodies are full of the planet's history, written in molecules that have flowed through every environment this world has ever had. We carry the fingerprints of ancient seas, the remnants of prehistoric storms, the chemistry of the first oceans. The rain is in our blood not as a metaphor but as a fact. It moves through our veins with every beat of the heart, the same way it once moved through rivers and tides. When scientists study the isotopes of water trapped in ancient minerals, they can tell where it came from, whether it condensed in Earth's early atmosphere, arrived on comets, or formed within the planet itself. But no matter the source, all of it has been recycled endlessly. There is no new water, only the same molecules moving through new forms. Every generation drinks from the same well of existence, shared across time. The glass of water on your table once flowed through the lungs of dinosaurs, through the roots of ancient trees, through the clouds that hung over a world without people. It may have fallen on a lava plain or frozen inside a glacier that no longer exists. It is, in every way, the same rain that once fell for 2 million years without stopping. Water has also shaped our evolution in ways that are easy to overlook. Our bodies developed in response to its presence. Our need to drink, our reliance on salt balance, our capacity to sweat and cool ourselves through evaporation. Even our tears, though emotional in function, are physical echoes of the planet's ancient processes. They are droplets that form, fall, and return, small acts of condensation and release that mirror the same exchanges between sky and sea. The rain is not something outside us, it is something that continues within us. Over time, as life spread across the planet, water became its universal connector. It carried seeds and spores across continents. It shaped climates, determined habitats, and guided migrations. Civilizations would one day form around rivers, lakes, and shores, drawn to the same substance that first gathered in the low places of a barren world. The rain that once built the oceans became the foundation of human history. Every culture, in every time, has looked to the sky and seen the same thing, the falling of water, the quiet reminder that we are part of something much older than ourselves. Even our bones carry traces of that connection. The calcium and phosphorus that make up their structure were once minerals dissolved in ancient seas, carried by rain into rivers and sediments, recycled through the planet's crust until life absorbed them again. When we grow, the materials that become our skeleton come from water, minerals that once moved with it, suspended in the same cycle. The solidity of our bodies is built from what rain once dissolved. There is a direct, unbroken line from the storms that cooled the planet to the bones that hold us upright. If you look at the chemical composition of the human body, it tells the same story as the Earth. We're about 60% water, and the rest is carbon, nitrogen, calcium, and other elements, all of which were shaped by water's movement across time. The rain that once sculpted mountains now shapes our internal landscape, dissolving nutrients, carrying oxygen, balancing temperature. Every cell depends on it. Without water, chemistry stops. Without chemistry, life stops. The rain didn't just give birth to life, it continues to maintain it, one molecule at a time. The persistence of water is also a kind of memory that predates awareness. It doesn't think, but it remembers through movement. It remembers where it's been by the way it shapes the world. The grooves in stone, the patterns in soil, the shape of riverbeds, all of them are records of water passing through. The same is true inside us. Our veins and arteries form patterns shaped by the flow of blood, the internal rivers that echo the ones outside. The rain that once carved valleys now carves channels in our bodies, defining the way we function. The planet's design and our own are built around the same principle, flow. In that sense, every living thing is part of the water's memory. The trees that pull it from the ground and send it back to the air, the animals that drink and exhale it, the clouds that carry it across the planet, all are participating in the same continuous process. The rain moves through everything, uniting what would otherwise be separate. It's not just a resource, but a connection, a thread that ties every form of existence back to the same event, the long storm that made the world habitable. When we stand in the rain, we're standing inside that continuity. The droplets that touch our skin could have fallen anywhere, at any time, in any age. They could have been part of a prehistoric sea, a glacier, or a storm on the other side of the planet. In that moment, time collapses. The distance between the ancient and the present disappears. The same forces that shaped the early Earth are still at work, just gentler now, smaller, measured in minutes instead of millennia. But the principle is the same: condensation, gravity, release, renewal. There is no part of life untouched by this process. The air we breathe is regulated by water's movement. The carbon that circulates through ecosystems depends on rainfall and oceans. Even the oxygen we inhale comes from water, split by sunlight in the cells of algae and plants that use it to make energy. Without the rain, there would be no air fit to breathe. The sky and the sea, the clouds and the forests, our lungs and our veins, all of them are extensions of the same original system. The rain that once fell for 2 million years created not just the oceans, but the conditions that would one day allow breath. The phrase, rain in our bones, might sound poetic, but it's literal. The water within us is older than any structure we've built, any memory we've kept, any word we've spoken. It existed before continents, before life, before time as we measure it. It is the continuity that binds every version of the Earth together, from the molten world beneath clouds of steam to the one that now supports forests and cities. When we lift a glass of water to our lips, we are drinking the planet's own memory, carried forward from an age when the sky fell for 2 million years without rest. And so, in every heartbeat, every breath, every quiet moment where the sound of rain fills the air, we're reminded of that connection. The water that built the oceans moves through us, rests in us, and returns to the world through us. The same molecules that once shaped continents now shape our bodies. The story of the Earth and the story of life are not separate stories at all. They are one, told in the language of water, a language that never ends, only repeats. The rain still falls, and when it does, the planet remembers itself. The clouds gather, condense and release, just as they did at the beginning. Each drop that touches the ground carries with it the memory of the first storm, the same patient rhythm that has carried on without interruption for billions of years. And in that same rhythm, quietly and without ceremony, we live, breathe, and move. Extensions of the same water, shaped by the same gravity, written into the same cycle that has never stopped turning. The sky above us may look empty, but it is full of memory. Every cloud that drifts across it is part of an ancient repetition, a pattern that began long before there were eyes to see it. The air we breathe carries invisible traces of vapour rising from the oceans, the same process that once wrapped the entire planet in steam. The clouds we see today are lighter, more fleeting, but they are made from the same substance, shaped by the same rules. The rain has never stopped falling, and the sky has never stopped remembering. If you watch the sky for long enough, you can see its memory in motion. Warm air rises from the ground, carrying moisture with it. As it rises, it cools, and that moisture condenses into droplets too small to see. Those droplets gather together, forming the soft grey shapes we call clouds. The air holds them aloft until gravity and temperature pull them back down again. It's the same cycle that began billions of years ago, when the Earth first cooled enough for vapour to condense. Every time the sky clears and fills again, it is performing that same act, over and over, with perfect precision and no awareness. The planet has been breathing through its sky for most of its life, inhaling and exhaling through the condensation of water. The atmosphere today is thin and light compared to what it once was, but it still carries the same ingredients. Water vapour makes up only a small fraction of it, a few percent at most. Yet that small amount governs almost everything about the planet's climate. It regulates temperature, drives wind, and distributes heat from the equator to the poles. When water evaporates, it absorbs energy. When it condenses, it releases it. This transfer of energy is what powers weather. Every breeze, every storm, every gentle fall of rain is part of this exchange. The sky still balancing itself, still seeking the same equilibrium it found when the first rains fell for 2 million years. There's a quiet persistence to the way the sky behaves. Clouds form whether anyone is watching or not. They move in patterns that have existed since the beginning, rising over warm seas, drifting inland, releasing rain where the air cools. On some level, it's easy to forget that these everyday movements are the continuation of planetary processes that started when the world itself was still forming. These same molecules of water that once condensed from volcanic steam are still rising and falling, forming clouds and vanishing into clear air. The sky remembers through motion. The water cycle, evaporation, condensation, precipitation, is the most enduring rhythm the planet knows. It has never stopped, only shifted in form as the continents moved and the atmosphere changed. When we see fog settling over fields or frost forming on glass, We are witnessing the same physics that once turned a molten world into a blue one. The laws have never changed. The scale has. What was once a planetary downpour has become a scattered pattern of storms, rain showers and drizzles spread across continents and oceans. But the principle remains the same. The sky condenses its own memory, and the Earth absorbs it. On clear days, when the sky seems to stretch without a mark from horizon to horizon, it is still full of water, invisible but waiting. Even the driest air contains vapour, molecules lifted from rivers, plants, oceans, and our own breath. Those molecules drift, carried by winds that span entire hemispheres, until they find the right conditions to condense again. The rain that falls in one place may have begun as vapour on the other side of the planet. The same drop that once fell into an ocean can rise again as mist from a distant lake, carried across mountains, falling on soil that remembers none of its origins. The sky doesn't forget. It just moves its memories endlessly, distributing them with the patience of time. The clouds themselves are archives of this motion. Their shapes tell the story of temperature, wind, and altitude. Thin cirrus clouds, stretched high and cold, form from ice crystals where the air is too dry for liquid droplets to exist. Thick cumulonimbus towers, bright and heavy, rise from warm air full of moisture, releasing rain and lightning as they collapse. Each type of cloud is a reflection of the world below it. The warmth of the surface, the movement of the air, the moisture of the oceans. The sky is not separate from the earth, but its mirror, responding to every shift in the land and sea. In this way, it remembers everything that happens below. The rain that falls from those clouds completes the connection. It carries with it particles from the air, dust, salt, pollen, ash, and delivers them back to the ground. Some of those particles rise again, carried by the wind to form the seeds of new clouds. The cycle repeats endlessly, a loop so continuous it erases the distinction between beginning and end. The water in the sky is the same water that lies in the oceans, the same that runs through rivers, the same that once filled the air when the earth was new. Every storm is a repetition of that first great one, softer now but identical in purpose. The memory of the first rains also lives in the chemistry of the atmosphere. The same reactions that once stripped carbon dioxide from the air continue to this day, though on a smaller scale. When rain falls, it absorbs gases and reacts with minerals on the surface, gradually shaping the composition of both air and land. This constant exchange has kept the planet's climate stable for billions of years. The sky cools itself by giving its moisture to the earth, and the earth regulates itself by returning that moisture as vapour. The balance is delicate, but it is steady. It is the system that has allowed life to thrive. If we could trace the movement of a single water molecule through time, we would find that it moves in patterns so vast they blur the boundaries of history. It might rise from an ocean, drift across continents, fall as snow on a mountain, melt into a river, and return to the sea. Along the way, it might pass through a leaf, a lung, or a cloud again. The time it takes to complete this journey can be days or thousands of years, depending on where it travels. Yet, in every step, it follows the same rules: temperature, pressure, gravity, light. The sky has been repeating this choreography for billions of years without ever tiring of it. The clouds, though ephemeral, are among the most enduring features of the planet. They have been part of Earth's atmosphere since the very beginning, changing in shape and composition, but never disappearing entirely. Even when the planet was covered in ice, clouds continued to form. Even when deserts expanded, they hovered above, waiting for heat and moisture to return. The sky has always remembered water, even when the ground forgets. In every era, in every climate, it keeps that memory alive by lifting and releasing moisture in a constant exchange. There is also a rhythm to how the sky remembers. Each region of the planet has its own pattern of evaporation and rain, shaped by geography and season. Warm air rises near the equator, cools, and drops rain before moving toward the poles. This circulation, known as the Hadley cell, has existed for most of Earth's history. It is the global version of breathing, air rising, cooling, sinking and rising again. The same pattern repeats at smaller scales everywhere, from mountain ranges to coastlines. The result is a complex web of interlocking rhythms, all governed by water's movement between sky and surface. The system is vast, but every part of it obeys the same ancient principle that once filled the world with rain. The memory of that ancient storm is also visible in the sky's chemistry. The proportions of gases, nitrogen, oxygen, water vapour, carbon dioxide, are not random. They are the product of billions of years of balance between ocean and atmosphere. The rain that once pulled carbon from the air continues to do so today, dissolving it into rivers and seas. The oxygen that fills our lungs exists because water, through photosynthesis, became a source of life rather than just a solvent. The connection between the sky and life has deepened over time, but its foundation was laid when the first clouds formed and the first rain fell. The sky still holds that origin within its structure. When you look up at a clear blue sky, what you're seeing is scattering, light bouncing off molecules of nitrogen and oxygen, the same molecules that once formed in volcanic gas and were washed clean by the rain. The colour is not just aesthetic, it's a sign of what the rain achieved. Without water to remove dust and heavy gases, the air would still be thick and orange, like the skies of Venus. The blueness of our atmosphere is proof that the rain once fell long enough and hard enough to purify it. Every clear day is a reminder of that process, the sky's way of remembering what it once was and what it became. Even storms carry memory in their structure. The way clouds build, the way lightning forms, the sound of thunder rolling across the horizon. All of it is the same interaction of heat, moisture, and gravity that shaped the first storms. The difference is scale. Where once the entire planet was a single storm, now each weather system is a small echo of it. The sky can no longer flood the world, but it still knows how to build energy, how to release it, how to cool itself through rain. Every storm is the sky rehearsing its history. The sky also remembers through its relationship with the sea. The two are inseparable, one feeding the other in an endless conversation. When the ocean warms, it sends more vapour into the air, thickening clouds and bringing rain. When the air cools, it allows the oceans to rest, storing heat until it's needed again. This dialogue between sky and sea is constant, quiet, and unbroken. It keeps the planet's temperature within the narrow range where life can exist. It is the same conversation that began when the first oceans formed from falling rain. We often think of the sky as transient and the land as permanent, but in reality it's the opposite. The sky is eternal. It's the land that changes. Continents shift, mountains rise and erode, but the atmosphere continues its cycles without pause. The clouds we see today are direct descendants of the first clouds that ever formed. The molecules may be different, but the pattern is the same. The sky has held its memory through time, adjusting to every change below it but never forgetting its purpose. If we could listen closely enough, we might hear the faint sound of that continuity, the whisper of wind through trees, the rush of air before rain, the quiet drip of water after a storm. These are not just sounds of weather, but echoes of the planet's oldest rhythm. The sky still speaks in the same language it used billions of years ago, though the words have softened. It remembers through repetition, through the endless cycle of lifting and falling, condensing and dissolving. When clouds gather before a storm, they are not forming for the first time. They are part of a pattern older than the continents beneath them. When the first drops fall, they are part of a memory older than life. The sky does not know this, but the earth does. The interaction between air, water and land is the memory of creation continuing in real time. It's the same mechanism that cooled the planet, that made it habitable, that keeps it balanced now. The sky has not changed its nature, it has only refined it. Even now, when we watch rain fall on modern cities or forests or deserts, the process is identical to what happened on a molten Earth. The difference lies only in what the water touches. The clouds form, the droplets grow heavy and gravity pulls them down. They strike surfaces, now rooftops, leaves, stone, skin, and return to the air as a vapour. The same molecules that once fell on lava plains now fall on us. The sky still remembers every step of the process, even if we no longer notice it. And somewhere, high above, the upper layers of the atmosphere still hold traces of the earliest vapour, the remnants of gases that have been circulating since the beginning. These traces are vanishingly small, but they are there, drifting with the winds, orbiting the planet in currents that never rest. They are the memory of the first clouds, preserved in motion rather than form. The sky keeps its history not by holding on to the past, but by continuing it. When we look up at the night sky, when the clouds part and the stars appear, we're seeing beyond the atmosphere. But even that view depends on the clarity that water brought. Without the rain to cleanse it, the air would still be too thick to see through. The visibility of the cosmos from Earth is another gift of the sky's long memory. Every clear night, every visible star is possible because the planet once washed itself clean. The transparency we take for granted is the result of rain. The sky remembers everything it has ever been. Steam, storm, vapour, and calm. It remembers through every droplet that rises and falls, through every gust of wind, through every quiet moment after rain when the air feels heavy and still. It is not a conscious memory, but a physical one, written into the way molecules behave. The laws that govern condensation and evaporation have never changed, and so the sky continues its oldest habit: to rise, to cool, to fall, to rise again. It is the simplest memory imaginable, but it has outlasted everything else. When the rain comes again, as it always does, the sky is not creating something new. It is repeating itself, rehearsing the same moment it has lived since the world began. The sound of raindrops on roofs, on trees, on the ground is the sound of that memory in motion, the quiet continuation of a process that began when the first clouds condensed over a molten sea. The sky still remembers, and it shows that memory every time it lets go. If you listen closely during rain, you can hear something familiar, not familiar in memory, but in instinct. It's the sound of repetition older than anything alive, the continuation of a pattern that began when the sky first learned how to let go. Each drop that strikes the ground is a small echo of that first great storm, the one that fell for 2 million years without pause. The sound we hear now, soft against rooftops or leaves or soil, is the same rhythm that cooled a molten planet and turned vapour into sea. The sky may have changed its tone, but the music has never stopped. Every time it rains, the atmosphere reenacts its own origin. Warm air rises, vapour condenses, droplets form and fall, carrying heat downward. The surface cools, the air clears, and the cycle continues. It's the same mechanism that once transformed a fiery world into a blue one. We live inside that repetition every day, though we rarely think of it. The rain that falls outside our windows, that gathers in gutters and rivers, is the same water that built the oceans, the same that has cycled through the atmosphere since the beginning. The echo of the first rain is not a metaphor. It's a physical continuity. The planet has been repeating the same process for billions of years, refining it, balancing it, keeping itself alive through rhythm alone. The sound of modern rain is gentler than the ancient storm, but the principle is identical. Gravity pulls vapour from the air, and in falling, it releases energy back to the surface. The earth cools a little, balances itself, and then waits for warmth to lift the water again. This exchange never ends. Even the stillest moments of calm between storms are part of the same cycle. The absence of rain is only the air gathering itself for its next descent. In that quiet, the memory of the first storm rests just beneath the surface, waiting for temperature and pressure to align once more. The echo of that ancient rain is also visible in the way the world responds to it. The rivers that cut through continents are the lasting tracks of water finding its way home. Their shapes are carved not by chance, but by the same physics that once guided entire oceans into basins. The erosion of rock, the formation of soil, the growth of valleys, all are consequences of that first deluge. Each new rainfall deepens those paths slightly, refreshing the memory of movement. When you trace a river's course from source to sea, you're following the same journey that began when vapour first condensed and fell upon a planet of fire. The pattern hasn't changed, only the scale has. The atmosphere too carries that memory in its movements. Every front, every wind, every storm that crosses the sky follows laws written during the earliest days of rain. Temperature differences, air pressure, rotation, all of these forces that shape weather were established when the Earth first cooled. The air today behaves as it did then, rising where it's warm, sinking where it's cool, carrying moisture in invisible currents across the surface. The difference is that now the system supports life. The echo of the first rain has become the climate we depend on, its rhythm slowed and softened by the balance that life itself helps maintain. The continuity between that first storm and the present is one of the most extraordinary facts of this planet. Nothing else in Earth's history has lasted so completely unchanged. Continents have drifted and collided, species have risen and vanished, atmospheres have come and gone, yet the water cycle endures. It is the same system, operating on the same rules, producing the same results. The rain that once fell on molten rock now falls on forests, deserts and cities, but it is still the same act: condensation, release, renewal. The echo of the first rain is not distant, it is immediate, surrounding us constantly, a low hum beneath everything we do. When you look at the clouds, you're looking at history. Each one forms from vapour that has been part of the planet since its beginning. Some of it was trapped in rocks, some frozen in glaciers, some drifting through the air for centuries. Every molecule has been through the cycle countless times, rising and falling, freezing and thawing, evaporating and condensing. The clouds above us are not new creations. They are reassemblies of ancient material. The sky keeps no archives, but it never forgets. Its memory is in circulation, always active, always reforming. The echo of the first rain exists in the way those clouds take shape, the way they hold for a while and then collapse, the way they fade back into invisible vapour when the balance changes. Even the scent of rain, the earthy electric smell that fills the air before a storm, is part of that ancient connection. It comes from compounds released by soil when water touches it, a reaction that has been occurring since the first land masses cooled. The air carries those molecules upward, mixing them with ozone and dust, creating a smell that we associate with renewal. That scent is the atmosphere remembering what it has done before, the contact between water and land, between sky and surface. It is the planet acknowledging itself. Every life form on Earth still depends on that exchange. Plants draw water from the ground, release it through their leaves, and send it back into the sky. Animals drink, exhale, and perspire, returning vapour to the air. Every breath contributes a tiny amount of moisture to the cycle. Even the act of burning fuel releases water as vapour, completing the same process in reverse. Everything living participates in the rhythm that began with the first rain. We are not outside of it. We are mechanisms of it. Each of us a small part of the system the planet uses to remember balance. The sound of rain has always meant calm to us, but it is more than that. It's the background noise of planetary function. When it falls softly, it signals that the system is working, that heat is being released, that the air is balanced. When it comes hard and fast, it shows the energy stored in the atmosphere has reached its limit. In either case, it's the same principle: condensation releasing what has been held too long. The Earth doesn't store tension, it cycles it. The rain is the sound of that release, the echo of the earliest balance being restored again and again. If you were to stand in the rain and imagine each droplet's history, the scope would be almost impossible to grasp. Some of the water falling on you might have last existed as vapour above the Pacific Ocean weeks ago. Some might have been trapped in polar ice for thousands of years. Some might have passed through the tissues of living things, through roots or rivers or clouds. Yet at some point in its journey, all of it was part of that original event, the long fall of the first rain. The continuity is unbroken, from that primordial storm to the drizzle you can feel on your hand. The same water, endlessly recycled, endlessly remembered. This persistence gives water an identity unlike anything else on the planet. Rocks are formed and eroded, metals corrode, air mixes and changes composition, but water remains what it is. It moves, it transforms, but it doesn't decay. It is both the witness and the participant in every age the Earth has known. The echo of the first rain exists in every ocean wave and in every ice crystal. It's in the fog that forms over valleys in the morning and in the dew that gathers on leaves at night. It's in the sweat that cools our skin, in the steam rising from a cup, in the clouds drifting quietly across the sky. The same pattern, the same material, the same endless return. When we speak of balance in nature, it is water that defines it. The rain falls, the oceans rise, the rivers flow, and then all of it returns to the air. The timing may change, the path may differ, but the sum remains the same. The planet's comfort, its temperature, its capacity for life, all of it depends on the persistence of this exchange. The first rain didn't just cool the Earth, it gave it a system for endurance. The echo of that event is what keeps the world from freezing or burning, from chaos or stillness. It is the mechanism through which the Earth maintains itself, the soft, steady pulse that underlies every storm and every clear day. If you listen to recordings of rain, the gentle kind, the kind people use to fall asleep, you might notice something subtle. The sound is irregular but continuous. No two drops land the same way, but the overall rhythm never breaks. That balance between randomness and consistency is the same quality the planet found after the Great Flood. Each raindrop is unique, each storm unpredictable, yet the cycle as a whole never changes. It is stability built from motion. The echo of the first rain exists in that pattern, not in sameness, but in reliability. The system has been repeating itself for so long that it has become indistinguishable from permanence. The memory of that rain extends even beyond Earth. When scientists study the atmospheres of other planets, they look for water vapour, for clouds, for evidence of the same cycle. So far, Earth remains unique in its balance, not too hot for vapour to escape, not too cold for water to freeze permanently. The rain that fell for 2 million years created a system perfectly suited for life and for memory. It allowed the sky to become thin enough for light, thick enough for clouds, and dynamic enough for weather. That balance is the reason this world remains habitable while others do not. The echo of the first rain is what keeps the sky blue and the oceans liquid. It's what keeps the air moving and the ground fertile. In modern storms, you can still see fragments of that first cycle playing out. When dark clouds gather, when the air feels heavy, when the first drops begin to fall, the sky is performing a process as old as the planet itself. The rain that hits your window might contain molecules that were once steam rising from a volcanic vent 4 billion years ago. The wind that carries it might be following patterns first shaped when continents were still molten. Nothing in the system is new, only renewed. Every storm is a rehearsal, a continuation of the original performance that never ended. When the rain stops, when the last drops fall and the air grows still, the sky returns to its balance. The surfaces glisten for a while, then dry. The moisture rises again, invisible but inevitable. The silence after rain is not absence, it's intermission. The next cycle is already beginning. Somewhere, vapour is rising, clouds are forming, and the process is repeating. The planet has never truly been without rain. It has only shifted where and when it falls. Even in the driest deserts, vapour moves through the air, waiting for the smallest chance to condense. The memory of the first rain never leaves. It just moves quietly until conditions invite it back. This is the echo we live within, not just as listeners, but as participants. Every breath we exhale adds to the sky's moisture. Every river that reaches the ocean sends another contribution to the clouds. Every leaf that transpires, every puddle that evaporates, every bit of mist that lifts from the sea, all of it is the same continuous exchange. The rain does not fall on us. It falls through us, through every living thing, through every surface. Part of a cycle so vast it includes everything that has ever existed on this planet. If you stand outside during rain and close your eyes, you can almost feel the age of it. The coolness on your skin, the way the air thickens, the smell of wet ground. All of it is familiar because it's been happening for as long as the planet has existed. It is the sound and feel of balance. The echo of the first rain continues in every storm, every droplet, every flow of water from sky to sea to sky again. It's the quiet continuity that has carried the world from its earliest days to this one, unchanged in essence, infinite in form. The sky remembers, the oceans remember, and through them so do we. The water in our bodies once fell as rain before life existed, once hissed into steam against molten rock, once froze in the cold of space before finding a home here. Every part of us carries that history in its simplest chemical form. The echo of the first rain moves through our veins as surely as it moves through rivers. It fills our lungs in every breath of humid air. It cools our skin, nourishes the ground, and sustains everything that grows. The sound of rain is not just weather, it is recognition. It is the planet remembering itself, softly, continuously, without beginning or end. And when the last storm of a season fades, when the clouds drift apart and the light returns, the cycle continues quietly in the air above and the water below. The rain doesn't stop, it only waits. The echo never fades, it only softens. The same pattern that turned a fiery world into a calm one continues without interruption, patient as time itself. Every drop that falls today is part of that same story, carrying within it the memory of the first and the promise of the next.